Very good morning, all my dear students. How is everyone? So, definitely we are going to start with GOC part 2, the most important GOC part 2 of Alkene. It's GOC Alkene part 2. Alkene 1 we have completed with number of questions, and today we are going to start with this part 2, and definitely we will deal with NCERT based most expected questions, 100 questions. But before that, everyone, do let me know in the chat section, can you hear me? Can you see me? If I'm perfectly audible and visible, then I want to see the green signal, killer signs. Yes, you know the drill. Killer Science has shown that yes. Good morning, Kumar Shiva. Killer Science, Rebu, Man, Ravina, Mr. One Side. Wow. NEET aspirant, Chandana. So this is indicating that I'm perfectly audible and visible to all of you. Say yes. How's the Josh? Kids, do let me know. See how much homework I have done for you. You can see number of new questions. Can you see over here? See this side, very small is here, but you see number of questions. Whatever has been taught in part 1 of Alkene, questions are based on that, as well as new questions. Whatever I'm going to tell you today, the questions are based on that also. Wow, the fire I can see in the chat section, that indicates that yes, everyone is ready. So everyone is ready, and I think, is there anyone new? If you are new to this channel, your channel, that is Unacademy NEET English channel, if you're new, then like and subscribe. And our lovely students, regular students, you know you have to smash the like button. But those candidates who are new, let me give you a brief introduction. Myself, Harin Singh Parhyar, and these lovely students, they used to say, yes, they are saying that our lovely magical guru, HSP Baba. I did MTech. Where is MTech? MTech in 2004. And I was gold medalist, means MSc topper. See, MSc as well as MTech. And I have been teaching for the last 23 plus years. Produced number of ranks. It's not the correct word. I have produced the ranks 1, 2, 3 like that. It's all the students' hard work. I'm just the positive catalyst who is decreasing the activation energy and reaching towards the success. Your goal is achieved easily. So yes, everyone is here and everyone is ready. So let's see what is there. Hey everyone, see what is this? Everyone, NCERT based new questions. If you are standing over here, if you are here, you have to move towards like this. You have to go like this. See everyone, you have to go like this. You have to go like this, and you have to get the entry from here. And whatever I'm teaching and whatever I taught, if you are having that thing in your brain, then only you can solve these new questions. Questions are never tough. It all depends that whatever the homework is given by the teacher, you should have to have that concept in your brain. Then all the questions would have been done by you kids. So if whatever I told you, yes, on the previous lecture, in the previous section of GOC part, Alkenes part 1, if it is there in your brain, then you can do question. So here is question number 1. Kids, first let me know that you were present for the Alkene part 1. I want to see in the chat section. Fast, Chandana, Srinithi, Mr. One Side, Mrithalal, Clear Science. If you were present in Alkene part 1, then only the question can be done by you. First two let me know that yes, Mr. One Side, yeah, you are also there, Killer Science Man. Yes, first two let me know, everyone. Show me the thumbs up that you were present in Alkene part 1. Then starting 5 to 6 questions you can do, or 10 questions. Okay. So only one thumbs up I have seen, that of Killer Science. Rest of others absent. Okay. Those who were absent, they have to show some patience because they won't be able to do these questions. And if you were present, now see, kids, let me tell you one thing. How much dedication I'm showing for you. No, is there anyone who is making new questions, handwritten new questions for you? The whole night I have spent for making these questions, 100 questions, and from NCERT lines, handwritten. See how much time it requires. Now, Sri is there. Very good. Sri absent. Okay. Now, what's the answer of this question? What is the answer of this question? Do let me know. What is the answer of this question? Yes, you're taking this much of time. Then what's the use of studying with me? Killer Science is saying A. A. Everyone is going for A. Definitely your answer is absolutely correct. Absolutely correct. That this is alpha carbon, this is beta, and this will be the major. This will be your major product because this is your ZJ product, ZJ, and that is your minor because it is being your Hoffman product. Am I right? So those who have given this answer, their answer is absolutely correct. Always maintain one diary. Always write over there how much marks you are going to get. Now, ready for second question. So this is your second question in front of you. Just see to it, everyone. And fast, be fast. You can treat it like mock test. You can say this is your mock test. Only 6 to 7 questions I will give you. Then I will start part 2. I'm waiting for your answer, kids. Fast, fast. See, X can be chlorine, bromine, iodine, heat. What should be the product? You are taking too much time. This is not good. If this much of time you are going to take, how we can increase our speed, kids? Be fast. Ravina Guneshkaran. Fantastic, Aarti, that everyone's answer is correct. This is going to be the major. This will be maximum. D will be maximum. After D, this A will be, and after A, the B. This is the order. If we want to say order of formation, this is the order. That's fantastic. Congratulations. Now, question number 3. See, here is fluorine. Then what answer you are going to give? And be quick, fast, very fast. And remember that in your NEET examination, question will come from here only. All the questions you will get from HSP Baba's notes only in your exam. Remember that. Always keep it in your brain that you will get all the questions from here only, whatever I'm giving you. That is sure. That's for sure. Fast, fast. And if your answer is right, always show thumbs up. If you got wrong answer, thumbs down. This is only the communication between me and you. B. That's really fantastic. Answer is 100% correct. When fluorine is leaving group, then Hoffman is generally major. So in this question, this is the correct answer. Now see, there is no option. So let me solve for you. You just try to do it in your brain. This question is based on Hoffman's exhaustive elimination. Hoffman's exhaustive elimination. See, this is having 3 valency. It should be 1 methyl more here. One more methyl must be here, that quaternary ammonium salt. Now, these are alpha carbons. You can see this is alpha carbon, this is alpha, this is alpha, this is alpha, and this is being beta. One proton will go from here, and this will get negative charge, and nitrogen will withdraw electron, positive charge. So the answer will be, just do let me know everyone agreed for the answer. This question was asked in your AIMS examination. AIMS examination, this question has been asked. Everyone agreed? Do let me know that everyone agreed. Yes, yes. Now, see, another question. Options are given over here. Hoffman's exhaustive elimination. So what's your answer? And don't forget, show thumbs up, thumbs down. That speed should be maintained, man. Yes. So this is once again Hoffman's exhaustive elimination. You can see this is alpha carbon, this is alpha carbon, this is alpha, beta, beta, and here is also alpha, beta. Then which carbon ion is going to be more stable? Do let me know. This carbon ion is going to be more stable, or this carbon ion is going to be more stable, or this carbon ion is going to be more stable. This is 2 degree without resonance. This is 1 degree, but this is going to be 1 degree, simple 1 degree, only one side carbon. So this is going to be more stable, more stable. So this will form major product. This will be responsible for major product formation, and this will take electron from here, positive, negative. So ethene is going to be the major answer. Ethene will be maximum. Ethene, not B. C will be maximum. C will be maximum than this butane, then butene. That means the order will be first of all B, then C, then A. This will be the order of product formation. Agreed or not? Everyone agreed or not? Do let me know. Everyone agreed? Because this carbon ion is going to be more stable, because only this CH2 is donating electron. CH2 is donating electron, but here this propyl is donating electron. You can see this propyl is donating electron. That means more the bigger alkyl group, more electron donation will be there. Bigger the alkyl group, more electron donation, So less stable, less electron donation, more stable. Everyone got it? Now see, once again, you see, and just try to find out the answer. Yes, this class, see, will you get Sri? Just do let me know. Are you going to get these type of questions in any book? Is anyone is giving you? You just see the YouTube also. Is this much hard work is done by anyone? Is there anyone who's going to make new questions from NCERT lines? So Sri, definitely you are going to get selection from here only. This is the best channel. Our team is best. Now, I want to see the answer. Yes, everyone. Yeah, thank you, Killer Science. Now see, this is having alpha carbon, alpha carbon, alpha carbon. This is alpha, this is beta, 1 degree carbon ion, beta, 2 degree carbon ion. So definitely your 1 degree carbon ion is more stable. This is being more stable, more responsible for product formation. So butane, this C is going to be the major. This is answer, because this is going to form major product. Clear? Are you getting my point? Everyone, yes. C is the correct answer. See how many questions just on Hoffman exhaustive elimination. How many questions you are going to get? See to it. Rowdy boy, just try to give the answer. Rowdy boy, I'm waiting for your answer. Arti, man, everyone. Once again, Hoffman exhaustive elimination based question. I want to see your answer. Now see, this is alpha, this is alpha, this is alpha, this is beta. We have to focus on beta. This is beta. This beta is being 1 degree carbonyl, going to form 1 degree. This is beta. This is going to form 2 degree carbonyl. Now see, this is 2 degree, but near to this, what is this? Phenyl means what? Just focus over here. This phenyl means what? Phenyl means phenyl. And if you see phenyl, that means it will do resonance. This is stabilized by resonance. This carbonyl being stabilized by resonance. So this carbonyl is being more stable, and here negative, here positive. This will be the major product. So answer is none. None, because none of these are the answer. Answer will be CH3, CH, double bond CH, C6H5. This will be the major answer. That's why none was the correct answer. Everyone able to understand? Hey, everyone, do let me know that are you able to understand it? Wow, Rowdy Boy Gaming, you're liking it? That's really awesome. Now see, oh, this alkyne, you can see what alkyne is it? This also I've told you, preparation of alkene, CH3, C, triple bond C, CH3, this is but2-ine. If I do the numbering, it is but2-ine, 1, 2, 3, 4, but2-ine. Now do let me know what should be the answer. H2PDC. H2PDC, you know very well. Fast. Everyone fast. Be fast. Try to give the answer. This is very easy. C. Cis-but2-ene. Fantastic. Who has given the answer first? Yes, Killer Science and Ravina. Congratulations. And man, Arthi has given first of all the answer. That's really fantastic. Now, this is Lindlar's catalyst. What is this? Lindlar's catalyst. Do you remember? Do you remember? Now, oh, once again, your but2-ine. Do let me know what's the answer. This is but2-ine. It is for those kids, those who are unable to understand the bond line notation. This is but2-ine. What's your answer? This is once again your Lindlar's catalyst. Whether H2PDC is given, whether this much is given, this is Lindlar's catalyst, or this much is given, that is also Lindlar's catalyst. Now you will say, sir, what is this? How is it is possible? See, just to live a life, we need oxygen, water, and food. 3 things are required. But if we are having oxygen, water, food, along with this Audi, Porsche, big bungalow, number of servants, then also we are going to live. So this is like that. A person is having oxygen, water, food, along with hi-fi car, servants, whatever. So this is also Lindlar's catalyst. Lindlar's catalyst. So what answer you are going to get? What answer? Everyone, what's answer? Cis-but2-ene. Fantastic. Cis-but2-ene. Now, this, so you know what answer is possible for this question. What answer you are going to get? You know, this is Birch reduction. Birch, B-I-R-C-H. Birch reduction. This name is not given in NCERT, but the reactions are given in NCERT. Only those kids, those who have gone through, those who have done the homework, they are going to get the correct answer. Yes, trans-but2-ene is the correct answer. Trans-but2-ene is the correct answer. H2 nickel. Kids, do let me know first thing that whatever I taught you, first do let me know everyone, whatever I taught you, Questions are based on that only. All these questions are from NCRT. NCRT lines or not, do let me know in the chat section. And see, whatever I taught you, whatever I explained in the previous lecture, see, I have formed questions on basis of that. And today, what I am going to tell you, I have also framed the questions based on that topic also. Now, yes, what's the answer? What's the answer? You know, H2 nickel, complete reduction, reduction. This is going to do complete reduction. This is going to show complete reduction, complete reduction. So what should be the answer? There are 4 carbons. There are 4 carbons. So you will get an alkane of 4 carbon atoms. What's that? Butane is the correct answer. Butane will be the correct answer. Now, E2 reaction follows which mechanism? This I have told you in detail. If you remember this thing I have told you in detail. E2 reaction follows which mechanism? So the answer is it follows anti-periplanar mechanism. Do you remember? Do you remember? Now see, CH3, CH2, CHX, CH3, KOH alcoholic, major product. Awesome question. Let's see who is going to give the correct answer for this question. I'm waiting for your answer. While coming to the class, you should have to have this much of knowledge. If the homework should have been done by you, then definitely these questions would have been done by you. Let me check it out, what answer you are going to give. I'm waiting for your answer, kids. So answer is depends on halogen, because if this halogen is chlorine, bromine, iodine, then ZF and ZSM means same. And if this X is fluorine, then the Hoffman. So depends on X. If X is fluorine, then Hoffman, otherwise ZF, ZSM. Answer you are going to get. Now, for this, we have to study. Then only you will be able to answer this question. Because we have started, yes, chemical properties of alkene. Do you remember? Now, this question, let me tell you how to do it. How to do it. This is really awesome question. This is really. So everyone, come on. If you were absent in the previous lecture, now I'm going to start with GOC part 2. Are you ready? Everyone, do let me know. Are you ready? So I am going to start with GOC part 2. Everyone, do let me know that. Are you ready? Now, to do this question, think about that HX. HX is going to add. Now, once the H plus is going to attack on this reaction, H plus is going to attack. Now, H plus will attack on this carbon. So this is being delta negative, this is being delta positive. What carbocation we are going to get in this? We are going to get this carbocation CH plus CH2 and one hydrogen. This hydrogen has been added. Now see, this carbocation is doing resonance with this. Just see to it. Tick, 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 tick. This carbocation is doing resonance, stabilized by resonance. This carbocation is very happy because this is stabilized by resonance. Isn't it? Are you able to understand, everyone? Are you able to understand? Is it clear? Yes, sir. Now, if the proton is going to attack on this carbon, see, the proton is going to attack on this carbon. This proton is going to attack on this carbon, negative, positive. What carbocation you are going to get? You will get this carbocation, CH2 positive, CH2, H. This is 1 degree carbocation. Is this carbocation stabilized by resonance? No resonance. Now, if proton is going to attack on this carbon, what carbocation you are going to get? CH positive and double bond CH2. Now, the most stable carbocation is this. Is this point clear? This is the most stable carbocation because stabilized by resonance. Most stable carbocation. Now see kids, out of these two, if I say this is X carbocation, this is being Y carbocation, and this is being Z carbocation, what do you think in between Y and Z, which is going to be more stable? Definitely, this was sp2 hybridized carbon, its electronegativity was 2.75, and this is being sp hybridized carbon, its electronegativity is 3.25. So which is more electronegative carbon? This carbon is being more electronegative carbon. So I've told you that positive charge is more stable on less electronegative carbon. That positive charge is more stable on less electronegative carbon. Remember this point. What I am telling you, positive charge is more stable on less electronegative carbon. So definitely Y is going to be more stable. So number one, X is stable, X carbocation, then Y carbocation, then Z carbocation. This is the carbocation stability order. This is carbocation stability order. And rate of reaction is directly proportional to the stability of carbocation. Rate of reaction is directly proportional to the stability of carbocation. The one whose carbocation is more easily formed will have more rate of reaction. So definitely A, B, C. Killer signs, your answer is absolutely correct. That this is going to be the fastest. Alkene, then alkene, then alkyne. This is the rate of reaction. Alkene, alkene, and alkyne. Everyone, are you able to understand? Do let me know. Hey everyone, just do let me know that you are able to understand it or not. That whenever you are going to do reaction of addition reaction with HX, HF, HCl, HBr, HI, then the order will be maximum reactive is alkene, then alkene, and then alkyne. If you got it, show me the thumbs up along with green hearts for you, that by heart you are able to understand. Just do let me know. Okay, now today we are going to start with what? We are going to deal with the best reaction, that is addition of water. Addition of water. Second part is addition of water. Addition of water. Addition of water. Addition of water. This addition of water follows three types of mechanism, three types of processes. Just see to it, what are they? First, second, and third. First, second, and third. Just try to understand, because this is very, very important, and you will study this thing in class 12th also. Once if you are able to complete it in class 11th, then class 12th will be the happiest days. Now, first is acidic hydration. Acidic hydration. Acidic hydration. That means addition of water in acidic medium. This follows rearrangement. I will let you know. And second is being Oxymercuration-demercuration, OMDM reaction. And third is HBO, brown hydroboration oxidation, brown hydroboration oxidation, hydroboration-oxidation. And the full form of this is oxymercuration-demercuration. Oxymercuration-demercuration. Try to understand, try to keep all the things in your brain. Demercuration, oxymercuration, demercuration. Now kids, these three are really very important. But let me tell you, the first one, acidic hydration, involves rearrangement. Rearrangement may take place. I will let you know each and everything in detail with the mechanism. But right now, put in your mind that rearrangement may take place in this reaction. Rearrangement may take place. But in this, no rearrangement reaction, and it follows Markovnikov's addition of water, Markovnikov's addition. And here also no rearrangement reaction, no rearrangement, and it follows anti-Markovnikov's addition of water, anti-Markovnikov's. Now kids, let me tell you one more thing, the important thing. Here the mixture of alcohols is produced. Mixture of alcohols. In this reaction, you will get mixture of alcohols. And in case of alcohol, mixture is not required. Mixture of alcohol is produced. Here, pure alcohol is formed in this reaction. Pure alcohol will be formed in this reaction. Pure alcohol. And here also, pure alcohol is formed. Pure alcohol. Now, number of questions must be arising in your brain, isn't it? Your brain must be saying why it's happening like this. So, how many of you are ready to understand it? But remember that don't even leave for a single second. Yes, please sit with pen and copy. Whenever question is going to come, try to understand it. Just don't keep it procrastination, Number of students are there. Most of the students are like, I will do it later on. Just, I will see to it. I will learn it later on before the test. No kids, right now try to understand it. Then only you are going to do anything. Now, let's start one by one. I'm going to start with acidic hydration. Is everyone ready? First acidic hydration, then oxymercuration-demercuration, then HBO reaction. I will let you know each and every reaction one by one. Are you ready? Just make a promise to yourself that yes, you are not going to live for a single second. So we are going to start with acidic hydration. Acidic hydration. Acidic hydration. Acidic hydration means addition of water in presence of H2SO4, or any other acid. Now, how many of you want to do the question by yourself? Even though I haven't told you anything, try to understand. This question you can do yourself. Try to understand. Just focus, kids. Now, today I am going to show you the magic. Suppose you are provided with this CH3, CH double bond CH2, plus water plus H2SO4. Let us suppose these three types of persons are in train. These are the three types of persons, they are in train. Now, you know that when number of people are sitting in the train, that no one is going to talk to each other. Once somebody starts talking, then everyone is going to participate in that talk. Then it becomes talk of the town. But who is going to initiate? See, this is propane, this is water, this is H2SO4. Who is going to start the reaction? The one who is highly unstable. The one who is easily going to start. Who is that? Definitely, oh my God, Killer Science to has given even the answer. I am just see, H2SO4 is strong acid. H2SO4 being a strong acid, this is going to start the reaction, isn't it? What H2SO4 is famous for? H2SO4 is famous for what? It is famous for donating proton. It will donate proton. Now see, these are pi electrons, and you see these are also pi electrons, but oxygen's electronegativity is 3.5, highly electronegative, and this carbon's electronegativity is just 2.75. This proton is searching for electrons. Proton is saying, oh God, I'm just searching for electrons. Yes, this proton can easily snatch electron from this oxygen, which is highly electronegative, or this carbon. Just do let me know that oxygen is debunk. Yes, villain type, that my electronegativity is 3.5. It's not easy to snatch electron from me. I'm highly electronegative. I'm not going to donate electron. So definitely this proton will reach to this carbon. Now both the carbon are having this electron. So this proton will reach to this carbon also, and this proton will reach to this carbon also, isn't it? This proton will reach to both the carbons. So two types of carbocations will be formed. See to it. What are these two types of carbocations? One carbocation CH3, CH plus CH2H. This is, let us suppose, X carbocation, and it is attacking over here. You will get CH3, CHH, CH2 positive. Just try to understand, this is Y carbocation. The X carbocation is 2-degree carbocation. It is having 3 alpha hydrogen, 2 alpha hydrogen. How many alpha hydrogen? 3 alpha hydrogen and 2 alpha hydrogens. So total 5 alpha hydrogen atoms. So it's stabilized by hyperconjugation and it is attached with 2 carbons. So it is 2-degree carbocation. So plus I effect, 2-degree carbocation. Now see, it is having just 2 alpha hydrogens, so it's stabilized by hyperconjugation, just 2 alpha hydrogen, and it is attached with 1 carbon, so 1-degree carbocation. Do let me know which carbocation is being more stable. Everyone, which carbocation is being more stable? Definitely this carbocation is being more stable. More stable carbocation, more formed. More stable carbocation, more formed, more responsible for product formation. This is less stable carbocation. People are not going to make the product of this. Less stable, less formed, and less responsible for product formation. This is less stable, so less formed, is formed in less amount, so minor product. It is going to form minor product. Now still they are carbocation. They want that this water should donate, or this water should form a bond with this. Now see what water is going to do. Everyone say to it, what water is going to do. CH3, CH plus CH3. This carbocation is having 6 electrons in the valence shell. It has approached to water. Hey water, please help me. Hey water, please help me. you are having lone pair, I'm having just 6 electrons, please donate your 1 electron. And he has snatched 1 electron. This carbon is snatcher. It is a need electron deficient, that is nucleophile, this is being electrophile. Are you getting my point? This is being electrophile, electron seeking, electron loving, electrophile, and that is being nucleophile, nucleophile. So it has snatched 1 electron. So oxygen started crying, oh, I have lost my 1 electron, I have lost my electron. Keep on crying, doesn't matter. So CH3, CH3. Now it has snatched 1 electron and oxygen has lost 1 electron. Now oxygen will look like this. Oxygen will look like this. Now this oxygen is having 7 electrons. This carbon is also having 7 electrons. What they will do? Everyone do let me know. Oxygen is having 7 electrons. Carbon is having 7 electrons. Right now no one is stable. They will say, oh dear, sharing is caring. Please, would you like to form a bond with me? Please come and form a bond with me. That sharing is caring and we are going to form a bond. Now see what is going to happen. CH3, CH3, and this oxygen will say, okay dear, let's form a bond. Now oxygen has developed positive charge. When carbon was having positive charge, we will say carbocation. When carbon is having positive charge, we will say carbocation. But once the oxygen is having positive charge, we will say oxonium ion. That is carbonium ion, carbocation, or we can say carbonium ion, and that is being oxonium ion. Now oxygen will say, oh, I can't tolerate this positive charge. I can't tolerate this positive charge. I will eliminate out this proton. So this proton has eliminated out and the picture got completed. In this way, they are going to live a happy life. Kids, now they are going to live happy life. This is your major product, and like this you will get your minor product, CH3, CH2, OH. This is your minor product, but you got mixture of alcohols. Kids, what do you think? Is this reaction cramming part is required, or this is just mathematical to understand it? Kids, everyone do let me know. Is this the reaction just for cramming, or you can do any question? Everyone do let me know. I want to see your opinion. Now try to solve this question. Everyone, if you are able to understand, try to solve this question. I want to see how much you are able to understand. Just try to do it in your brain, and then I'm going to write the answer and try to find out whatever you are going to get. I have written the same product or different product. This H plus will attack over here. See the mechanism. I'm going to start the mechanism. Everyone, see to it. I'm going to start with the mechanism. So mechanism part. This H2SO4, H plus will come and attack on this carbon, right? Agreed? This is going to attack on the carbon. So you will get a carbocation like this. Now, once the carbocation is formed, what is required? Once the carbocation is formed, always remember one thing in your brain, that think about rearrangement. Always, once the carbocation is formed, always think about what? Always think about, kids, think about rearrangement. I must have told you in the previous lecture. I have told you or not? Answer is yes, sir. You told us that this point is very, very important, that we have to think about rearrangement. Without rearrangement, we are not going to do anything. So think about rearrangement. Everyone, do you remember? Just to let me know, do you remember? Think about rearrangement. Now, if 1,2 hydride shift is taking place, 1,2 hydride shift, 1,2 hydride shift, then what will happen? The plus charge will come over here and that will get resonance stabilized. So we are going to do the shifting 1,2 hydride shift, and after 1,2 hydride shift, it will look like this. It will look like this: CH plus, CH2, CH3. Now this carbocation, that carbocation was without resonance. Without resonance, less stable. Without resonance, less stable, right? This carbocation is stabilized by resonance, isn't it? Stabilized by resonance. So this carbocation is more stable, more responsible for product formation. So this will be attacked by water and proton will eliminate it out. So you will get major answer as, so examiner will ask about this only, that this is being your major product. Now kids, you must be thinking one thing, that it was here, why you kept at ortho? See, both are same. If in benzene only one alkyl group is there, they will be same. Kids, is this the cramming part, or you can form any product? Just do let me know. Product's name is not required, but if you want to, I can tell you. Otherwise, name is not required. See, 1, 2, 3. 1 phenyl propanol. 1 phenyl propanol. Name is not important, but product is important. Kids, do let me know. Everyone is able to understand. Now I'm going to deal with oxymercuration-demercuration reaction. You can form, yes, killer sciences, definitely responding within time. Others, everyone in the chat section, give the response. If you're not responding, either you can show thumbs up if you don't want to write, if your speed is not that good, but always try to. Yes, Aarti, very good. Now let me tell you another reaction, very, very important reaction. Oxymercuration-demercuration reaction. Is everyone ready? Is everyone ready for oxymercuration-demercuration reaction? This is very, very important reaction. Just do let me know that everyone is ready for it or not. Oxymercuration-demercuration. What a name! Oxymercuration. Everyone say oxymercuration-demercuration reaction. Oxymercuration-demercuration reaction. Just everyone repeat: oxymercuration-demercuration reaction. This mercuration is not written properly. Oxymercuration-demercuration reaction. Let me write down once again. Everyone see, oxymercuration-demercuration reaction. Everyone say oxymercuration-demercuration reaction. Say everyone, oxymercuration-demercuration. Again, once again, marara, what is this? So let me write down myself only. This is not following the what I'm writing. So let me write down myself only. Oxymercuration-demercuration. Computer is getting confused. Oxymercuration-demercuration reaction. See, even computer got confused. What is the name I'm writing? Even the computer got confused. Oxymercuration-demercuration. In short, we will say OMDM. It's a big name, so we will say OMDM reaction. Now see what is going to happen over here. What reagent is used? So if I write, suppose CH3, CH double bond CH2. Now, what reagent is used over here? This is really very, very important. Think about it. The reagent. Reagent is, yes, anyone? Is there anyone who is going to tell me what reagent is used in oxymercuration-demercuration reaction? Mercuric acetate, CH3, COO whole twice, Hg, mercuric acetate. This is mercuric acetate, mercuric acetate, mercuric acetate. THF, tetrahydrofuran, tetrahydrofuran, tetrahydrofuran. How it is going to form its structure? The tetrahydrofuran is like this. This is tetrahydrofuran as solvent. Then water. Not only this much. This is the first slot. After this has been consumed, then you are supposed to add to it NaBH4, sodium boron hydride. The name is sodium boron hydride, sodium boron hydride. Now, then OH negative plus OH negative. If you are adding these many things you are going to add, then what you will get? Simply you will get CH3, CH, OH, CH3. This product you will get, but pure product you will get. Now see, now it's very tough to remember these reagents, isn't it? Will you be able to learn these reagents? Mercury acetate, THF water, NaBH4 boron hydride. Is it possible to learn? Yes, try to learn it. And mercuric acetate can be written like this also. See, mercuric acetate, CH3, C double bond O, OHG, O, C double bond O, CH3. And for this much part, some people used to write AC. So how we can write it? It can also be written as AC, O, HG, O, AC. So we can write it like this also. AC, O, whole twice, HG. Can we write like this? See kids, all they are correct. This is mercuric acetate, this is mercuric acetate, and this is also being mercuric acetate. In any form, you can get mercuric acetate. Everyone, is that clear? Now, question arises, why it forms the pure product? What's the reason? Just try to understand why the rearrangement is not going to take place. So for that, we have to see the mechanism. Everyone ready for the mechanism? Do let me know. That is everyone ready for the mechanism? Now, step number one of this mechanism. See, step number one. The mercuric acetate CH3, C double bond O, OHG, O, C double bond O, CH3. You know that all of them are non-metals, but mercury is being metal. Do you remember? Mercury is metal. This is being the metallic part. And metals are very much famous for what? Metals are famous for donating electrons. So Mercury is saying, I wanna donate electron. Hey oxygen, you just keep your electron with yourself. I'm not interested in your electron. Now this acetate is saying, hey Mercury, what has happened to you? You were along with me, but now suddenly what happened to you? You got changed. No one knows what Mercury is thinking. Mercury has seen propene. See, Mercury has seen propene. And that's why it is going to break the bond with acetate. Step number two. Step number two. Everyone see to it. Step number one. Step number two. Step number one is step number two. Now this is the propene. Now why Mercury has broken the bond with that? Is there anyone who can understand why Mercury has broken the bond with that? Because oxygen's electronegativity is 3.5 and this carbon's electronegativity is just 2.75. This is less electronegative carbon. So Mercury is saying, oh, I wanna friendship. I want to make friendship with you. I want to make friendship with you. Oh, with both the carbon, this Mercury is saying, I want to make friendship with you. Yes, killer science. Jennifer, you got late. No problem. Try to understand. You will be able to understand. This is the first reaction where mechanism understanding is important. Now, this Mercury is saying, I will come in the life of both. I am a metal. I am electron donor. I will come in the life of both the carbons. Oh my God. What this Mercury is going to try. Now, what is going to happen? See, CH3, CH, CH2, and the mercury has formed with both the carbons, form a bond with both the carbons. Zupak, zupak. Now, oh my God, what has happened? What a mercury. Now see, this is having delta positive, this is having delta positive. Just try to understand, kids. This is the point which is very, very important. This is the point which is really very, very important, and you have to focus over here. What? See, this chemistry triangle has been formed. See, try to understand chemistry triangle. Just try to focus over here. This chemistry triangle. Chemistry triangle. Just like in movies, there is love triangle, but here chemistry triangle. Three-membered ring has been formed. This is the very, very important point. This three-membered ring. Once again, I am going to tell you, kids, focus over here. This three-membered ring is very, very important. This three-membered ring has been formed, and three-membered ring is not stable. This three-membered ring has been formed, and this is not stable. Three-membered ring. Three-membered, highly unstable. Three-membered, highly unstable ring. Now, this is known as mercurinium ion. Mercurinium ion. Just try to understand what is the name, because mercury is having positive charge. That's why the name of this intermediate is mercurinium ion. Mercurinium ion. Let me tell you, everyone, the very, very important point. Try to understand what I'm going to tell you. When carbon is having positive charge, we said When carbon was having positive charge, we said carbonium ion. When oxygen was having positive charge, we said oxonium ion. Now mercury is having positive charge, we are saying mercurinium ion. Now people must be asking, the question will be asked, is there carbonium ion formation? No carbonium ion. See, this is having delta positive. Now this is very, very important. Let me tell you very, very important point. Suppose if you are having 20 rupees or 30 rupees, if you are having 30 rupees or 20 rupees, is it possible to eat pizza? Is it possible to eat pizza with 30 rupees or 20 rupees? If you are having just 20 rupees or 30 rupees in your pocket, is it possible to eat pizza? No. Answer is no. But is it possible to eat samosa or toffee or chocolate? Yes. That means if you are having 20 rupees in your pocket, this much of money is not sufficient to eat pizza, but it is not that less that even you cannot eat samosa, chocolate or toffee. So this positive charge is enough to attract nucleophile, but it is not enough for the rearrangement to take place. This is the point to be noted, my lord. This positive charge is not enough. The positive charge on carbon is not enough for the rearrangement to take place, but it is sufficient to attract the nucleophile. So this is the most important point. The positive charge on carbon, the positive charge on carbon is not enough to carry out rearrangement, but it is sufficient but it is sufficient for nucleophile attack. Now one more thing, let me draw this mercurium ion next page so that I can tell you more better. Everyone see to it. CH3, CH2, and this was your mercury, delta positive carbon, delta positive mercury, O, CO, CH3. Now water will come and attack. But water will come from which side? Same side or opposite side? This water will come from the same side where mercury is forming ring, this ring, or it will come from back side. It will come from back side with its lone pair electrons. Just do let me know from which side it will come. From the same side where this mercury is forming a bond, or from opposite side, back side. This is known as anti-addition. This is known as anti-addition. Just keep in your brain, this is known as anti-addition. So from the back side, opposite side, it's forming a bond, and this is known as anti-addition. Now see what is going to happen. Both the carbon were thinking in the starting, this mercury is mine. Once the water has come to the life of this, what is going to happen? See, this mercury will be there. HgOCOCH3, and this water has formed a bond and proton has eliminated out. Now, after several steps, by applying NaBH4, sodium boron hydride, and OH negative, the demercuration will take place. Demercuration means mercury will eliminate out. Demercuration will take place, and in this way the reaction has been completed. Reaction has been completed. Now reaction has been completed. Gets everyone able to understand? So this has followed Markovnikov's rule. Very less students are there. I don't know that am I teaching good or not. Why these many less students are there? I am unable to understand. NaBH4, NaBHO4 not, NaBH4, just NaBH4. 2-butanol is the pure product formed. Everyone call more students. See, my teaching is valuable or not? Then why less students are there? I'm unable to understand. Excellent teaching, but then also kids, I'm teaching high-fi or I'm teaching from 0 level to rank 1. Do let me know in the chat section. I'm just telling you each and everything from 0 level up to the first rank level. But then also kids are coming, going, what they are doing? Not able to understand. Killer science, really good. Try to share it to most of the students, most of your friends. If I'm doing that much hard work and only if I see less students, I'm getting demotivated. Their mindset is that I will leave organic chemistry aside. Or is it possible to get selection? This time you must have seen in IIT as well as NEET, maximum portion was from organic chemistry only. No problem, let's come. Now, suppose if they are giving you question like this, see to it everyone. 2 questions I am going to give you, just try to understand. One is this question. CH2, CH double bond CH2. Okay. Now once if I am reacting with water and second time also I am reacting with water, first time I have added H2O in acidic medium and second time I have done OMDM reaction. What do you think? The major product in both will be same or different? Here major product and here major product will be same or different? Do let me know. Don't worry, I am not going to stop. I will teach the whole content. Don't worry, kids. Srinithi, don't worry. I will teach each and everything. Even one student is there, right? Different. Very good. Here, rearrangement case. In this, rearrangement will take place. Hydride shift. Hydride shift will be there. And here no rearrangement. If you are able to understand this much, then definitely you are going to get the correct answer. So see, if I say this is X and this is Y, then X will be CH OH CH2 CH3 and Y will be CH2 CHOH CH3. Is it clear to all of you? Is it clear? Now everyone try to understand. Wow, that's really. But kids, those who are present, and I will tell you each and everything, but you have to respond. Don't worry about others. We have to do the proper communication, right? Now, everyone try to understand. If examiner is going to give you this question, see, if examiner is going to give you this question, try to understand. If suppose examiner has given you this question, try to understand everyone, and he has given you OMDM reaction. Now the major product will be of how many carbon membered ring? Do let me know. A answer, 6 membered ring. Option B, 5 membered ring. What will be the answer? 5 membered ring or 6 membered ring? Do let me know, everyone. What's your answer? B. Yes, the answer B is absolutely correct. Now, those who are not able to understand, those who are not having in their brain, that rearrangement will not take place. What answer? 99% people will give what answer? Do let me know that 99% students will give what answer? Definitely they will say, I know ring expansion. They will do the ring expansion and they will get failed. Am I right or not? Most of the students will give this answer. Now, next is brown hydroboration oxidation reaction. Brown hydroboration oxidation reaction. Just try to find out what's the reaction. Brown hydroboration oxidation. Brown hydroboration oxidation reaction. This reaction says that we are having the same alkene propene CH2, CH double bond CH2, and we are doing the reaction with here BH3, or they can give you B2H6, BH3 or B2H6 diborane. Diborane is used, plus THF plus water, THF plus water. And after this, once this has been added, they will use H2O2, hydrogen peroxide, and OH negative, H2O2 OH negative. These many things, once they are going to use, then the product will follow anti-Marconic oxidation, and this will be the product, pure product, but it is following anti-Marconic oxidation. Now, you must be thinking that what mechanism is taking place. Everyone, do let me know, are you thinking? How many of you are in need of the mechanism by how this reaction is going to take place? So everyone is ready to understand the mechanism. Yes, that's really awesome. Now, see the mechanism of brown hydroboration oxidation reaction. Mechanism. Try to understand it. Mechanism says that your propene is like this, CH3, CH double bond CH2, and this is electron rich, and that's why it is being nucleophile. It is having electron rich entity, nucleophile. That is electron rich, right? Now BH3 is electron deficient. You can see BH3 is electron deficient, only 6 electrons. So it is being electrophile, right? It is being electrophile. Now, what is going to happen? Just try to understand by yourself, because if you're not applying your brain, you won't be able to understand. So apply your brain that BH3 will try to attack, and see which carbon it is going to attack. See, this methyl is plus I, it is donating plus I. So it is electron donating group, right? Once it is pushing, so this pi bond will shift over here. And this is gaining, this is getting negative charge, and this is getting positive charge. This is already happening in this compound. Inductive effect is permanent effect, and this thing is happening by itself. Now, this BH3 boron is being electron deficient, and definitely it is going to attack on which carbon? This is going to attack on this carbon. It will attack on this carbon. See how it is attacking on this carbon. Let me tell you the scene. CH3, CH positive, CH2 negative, 8 electrons, 6 electrons, and BH3, 6 electrons. 6 electrons. So this boron will take 1 electron of this carbon. Boron will take 1 electron of this carbon. Now once this electron has been taken by this boron, see what is going to happen, how it will look like. It will look like this: CH3, CH positive, CH2, and boron is with 7 electrons. Boron is with 7 electrons and 1 negative charge. 1 negative charge because boron is gainer. It has gained 1 electron, gainer, and this is being donor. So donor is negatively charged, it will become neutral, and that is neutral, it will become negatively charged, and they together will form a bond. They will form a bond. Can you see? They will form a bond. Now, by forming bond, this carbon is having 6 electrons, this is having 8 electrons, and this is also having 8 electrons, but boron got negatively charged. And charge is not a good thing. Charge is not a good thing. Are you getting my point? Charge is not a good thing. And boron's mommy is saying, hey boron, what you did? I told you you are too small. Don't form 4 valency. Boron's mama is saying, boron, I have told you, you belong to the second period. You are too small. You can't handle 4 valency. Just keep only 3. To keep and to handle 4 is not under your control. You can't handle 4 what valency, just have 3 only. Now, so this will transfer 1 hydride to this carbon. This will transfer 1 hydride to this carbon. It is going to transferring 1 hydride, transferring 1 hydride. Just see what is going to happen. The movie is moving like this only. So this is going to transfer 1 hydride, and by the transfer of 1 hydride, how it will look like, see to it. It will look like this: CH3, CH, CH2, and BH2, and this hydride is going to form with this carbon, positive and negative charge. Next part I'm going to tell you on next page. Just after this I'm going to tell you on next page. Turn on the page, please. Turn on page, please. Just see ahead what is going to happen. Now see what will happen. CH3, CH, CH2. Now this is your boron. 2 hydrogen are over here, and 1 hydrogen is going to be the part of this carbon. It's like this, and it is forming bond like this. Now it is forming a bond with this also. It is going to form a bond with this also. You can see how many membered ring is formed. This is the first time 4 membered ring has been formed. What membered ring is formed, kids? Do let me know what membered ring is formed. 4 membered ring is formed. 4 membered ring is formed. 4 membered ring is formed. and you just see very special thing. The side from which boron is added, same side this hydrogen is also getting added. This is known as syn addition. It is not coming from back side, this hydrogen is coming from same side, so this is known as syn addition. Syn addition, syn addition, syn addition. So whenever the question is being asked whether anti-addition or syn addition, so syn addition. Now see what is going to happen. What is going to happen? Just see and focus over here. CH3, CH, and one hydrogen I am writing yellow one because this hydrogen is coming from boron. By chance BD3 is given, BD3 in place of H, D is given, deuterium. So in place of H you are supposed to write D. Now CH2 and BH2, BH2, BH2. Now boron is happy. Boron told mama, I'm feeling very happy. Boron's mama is saying, why you are feeling happy? Boron is saying, mama, in the starting I was having 3 hydrogens and hydrogens were not giving me electrons. No help I was getting from hydrogen. Now this alkyl group is plus I. This alkyl group is plus I. It is electron donating group. It is helping me a lot with the donation of electron. I am feeling very good. I am feeling happy. Mama said, hey insane, what you are saying, what you did, you have just donated 1 hydrogen and you are feeling that much happy. Still you are having 2 more hydrogens. You are having 3 hydrogens. By donating 1 hydrogen you got the friendship with alkyl group. Now still you are having 2 more hydrogen. You can donate these 2 hydrogen and feel more happier, feel more happier. So boron is able to understand. Boron did the same what mama suggested. It has reacted with 2 more alkenes. It has reacted with 2 more alkenes. 2 more alkenes. Now in boron's life, how many alkyl groups are there? In boron's life, 3 alkyl groups are there. Everyone, are you able to understand? 3 alkyl groups are there. CH2, CH, CH3, CH2, CH, CH3, CH2, CH, CH3, one yellow hydrogen everywhere, H, H, H. This is the intermediate. This is known as trialkyl borane. This is the intermediate. What is the name of this intermediate, kids? Trialkyl borane. Trialkyl borane. Trialkyl borane. This can be written like this, or it can be written like this also. CH3, CH2, CH2 whole thrice B, trialkyl borane. Now after this, in number of steps, after this, in number of steps with H2O2 and OH negative, H2O2 and OH negative, what is going to form? 3 moles of CH3, CH2, CH2 OH plus BOH whole thrice will be the answer. It's anti-Markovnikov's addition. You got product. Is everyone able to understand? Is it clear to each and everyone? This point, can you understand? Let me write down once again on next page. If you're not able to understand, let me write down this thing on another page. It's too much congested over here. Let me write down on next page. CH3, CH2, CH2 whole thrice B will react with H2O2 OH negative. H2O2 OH negative, H2O2 OH negative. Now you will get 3 moles of CH3, CH2, CH2, OH plus BOH whole thrice, or you can write H3BO3. In this way, reaction has been completed. Now, kids, yes, bond slapped hydrogen. Now, just remember, if you're not able to understand in the examination, just apply Markovnikov, anti-Markovnikovs. Let me tell you, if by chance you're not able to understand in the examination what to do, what not to do, see, if I give you 3 types of reaction, just try to find out what's the answer. By chance, this hi-fi question has been asked in your examination. One thing, second thing, and third thing. 3 types of questions has been asked. See, what are the 3 types of question? H2O, H plus, OM, DM reaction, oxymercuration-demercuration, and brown hydroboration-oxidation. What you are supposed to do? In the first, rearrangement will take place. Rearrangement will take place. Ring expansion will take place. Ring expansion, because rearrangement will take place. So ring expansion will take place, and this will be the major product. OH, CH3. This will be the major product. Now, without rearrangement, no rearrangement, right? And what you are supposed to apply? Markovnikov's addition. Markovnikov's addition will be applied. Markovnikov's, and I've told you, when no rearrangement is going to take place, Markovnikov's addition of water, Markovnikov's addition of water, right? Addition of H2O. So Markovnikov's rule says negative part means of water, H plus OH negative. Negative part of the region will go to that carbon which has less number of hydrogen atoms. So without rearrangement means no ring expansion, and OH will be over here. Now this will follow anti-Markovnikov's addition of water. Anti-Markovnikov, right? Anti-Markovnikov's addition of water, right? Now this says that negative part will go to that carbon which has more number of hydrogen atoms. Without rearrangement, no rearrangement will take place. So the answer will be CH2OH. This is the short trick by HSP Baba. HSP Baba's short trick. Are you getting my point? Short trick. Short trick. This is the short trick. By this, you can do any question. You can do any question. This is the short trick. Is it clear, kids? Wow. Thank you, Killer Science. Aarti. Now, everyone is able to understand. Now, let me apply this thing on alkynes also. Let me apply these 2 rules on alkynes also, and then I will give you number of questions. Now, see. Everyone see to it. I'm going to apply this thing on alkynes also. See, everyone ready? See, if I say that I'm going to treat acetylene, CH triple bond CH. Now alkynes are least reactive, so along with water, what is supposed to be added? 1% HgSO4, 1% HgSO4 and 40% H2SO4. This reaction will be given like this. Or if this reaction is not given like this, they can give you like this. CH triple bond CH. They will simply give you water and they will write like this. Hg2 plus Hg2 plus H plus. Both will form the same product because both are same. Both are Same. Both of them are being same. Now, how to do this question? Reaction of alkyne with water. What is the heading? Alkynes plus water. Alkynes plus water. That is, if simply you can say OMDM reaction only, because mercury has been used, no rearrangement will take place. So any side, because this is symmetrical alkyne, this is being symmetrical alkyne, to any carbon you can add OH, to any carbon you can add H plus. Now see how to do this question. CH triple bond CH, let me say this is being delta positive, this is being delta negative, and you are supposed to add water. So water's H delta plus you have to add over here, and OH negative you have to add on this carbon. What will you get? You will get something like this. CH H double bond CH OH. Now kids, ethanol, wow, killer sign, that's really awesome. You know each and everything. Now tautomerism will take place. Tautomerism. How the tautomerism takes place? 1, 2, 3. Just shift H delta positive from first to third atom and double bond in between 1 and 2. What is tautomerism? Shift H from first atom to the third atom and double bond in between 1 and 2. What you will get? Tautomerize. You will get CH3 CH double bond O. Now kids, you will be saying, sir, I don't know tautomerism. There is one trick. If you don't know tautomerism, then let me tell you. See how to do it without tautomerism. HSP Baba's trick. HSP is going to give you the best trick. See, HSP trick. Any question you can solve within seconds. This is CH3 C triple bond CH. And what I'm saying, it is going to follow Markovnikov's rule. Once it is going to follow Markovnikov's rule, that water has been added and mercury is there. So mercury, when mercury is there, M for mercury, M for Markovnikov's rule. M for mercury, M for Markovnikov's rule. Markovnikov's rule. And what Markovnikov's rule says, that negative part of the reagent will go to which carbon? Which has less number of oxygen. So oxygen is being negative. Add oxygen to this carbon and proton to this carbon. What will you get? No tautomerism is required. Just add to this and add to this. What answer you are going to get, kids? Do let me know. You will get CH3 C double bond O CH3. Direct answer. No tautomerism is required. See to it. Without tautomerism, you got answer. Is it good or not? And the same thing is valid for HBO reaction also. See, HBO reaction. If I am going to give you another question, try to understand. Since if I give you this question, CH3 C triple bond CH, and they are giving you question like this, react it with this, BH3 THF water H2O2 OH negative. Oh my god, the student will say, oh my god, so lengthy. But what I am telling you, just apply HSP concept, anti-Markovnikov's addition. And anti-Markovnikov's addition says what? Negative part will go to which carbon? The CHSP's rule. Negative part will go to this and hydrogen to this carbon direct. Without doing anything, you will get answer. See, this H over here and this oxygen over here. What you are going to get? CH3, CH2 and CH double bond O. No tautomerism, nothing else is required. Just HSP's funda is required. HSP's funda, everyone will get the rank. Is everyone able to understand, kids? Do let me know that everyone is able to understand. See, you can apply this funda anywhere. You can apply this funda anywhere. All the questions will be solved by this funda. Just see if anyone is going to give you a question like this. Once the examiner in IIT, this question has been asked in IIT. Now, examiner has given that add H2O, Hg2 plus, H plus, and another time the question was given like this, BH3, THF, water, H2O2, OH negative. These many reagents, definitely students will start crying, but you have not to worry about anything. Just what you are supposed to do, in this, follow Markovnikov's rule. I've told you, just do the addition according to Markovnikov's rule. What you're supposed to do, add oxygen over here, 2 hydrogens over here, you will get the answer. Nothing to do. Directly you will get the answer. Answer will be this is your answer for this compound, and over here what you're supposed to do, just opposite to that, just opposite of that, right? What is that? Oxygen over here and 2 hydrogens over here. What answer you are going to get? So see, a work of hours or minutes you can solve in seconds. A thing of minutes has been completed within seconds. Everyone, do let me know that everyone is able to understand. This name is acetophenone. Yeah, very good. Its name is being acetophenone. Acetophenone. And this is simply acetophenone. Acetophenone is well-known compound. Kids, do let me know that everyone is able to understand. Let me deal with some questions and see whether you are able to do it or not. See how much homework I have done for you. First of all, do let me know that, kids, really I have done a lot of homework for you people or not. I have done a lot of homework for you people or not. Just do let me know, everyone. Try to find out the answer of this question. Yes, I'm waiting for your answer, everyone. D. Yeah, all they are same. All they are same. So whenever all of this is given, otherwise 99% students will take acetaldehyde. Once acetaldehyde they have seen, they will say yes, A is the answer. Whenever all of this is given, just see and go to all of these. Now, this question, with my fundamental things, short tricks, you can kill the question. It's done and dusted. Definitely you are going to get the answer. What's the answer of this question? It is HBO. HBO, anti-Markovnikov addition. Just what you have to follow. Anti-Markovnikov's addition, isn't it? Anti-Markovnikov's addition of water. and no shifting is there, then negative part will go to this carbon and positive part will go to this carbon. So your answer will be what? Definitely you're going to get this answer. See to it. CH3, CH2, CH2OH, propanol. Isn't it? How many of you got this answer? If you got this answer, show me thumbs up, otherwise thumbs down. Everyone, you have to participate, right? Thumbs up, thumbs down. Now, OMDM reaction. Now, you know OMDM reaction. M means what? Both the M's are indicating Markovnikov's addition of water. Markovnikov's addition of water, isn't it? Markovnikov's addition of water. So, what you're supposed to do? Add OH negative part at this carbon and H positive part on this carbon. You will get the answer. So, what answer you are going to get? You will get CH3, CHOH, CH3, propane to all. Propane to all. Everyone, do let me know. This is the answer you are getting. Now, HBO OMDM reaction. This is alkyne. Will you get the same answer or different answer? Everyone, do let me know. Are you going to get the same answer or different answer? Same answer or different answer? Do let me know, everyone. I'm waiting for your answer that you are going to get the same answer or different answer. So, this is being symmetrical alkyne. In case of symmetrical alkyne, you will get same answer. Any side you can add OH negative, OH. Either you do this or you can do otherwise opposite. So you're going to get same answer. Same answer you will get. Same answer. Same answer you will get, kids. What is the answer? The answer will be CH3, C double bond O, CH2, CH3. Either you write like this or you can write like this: CH3, CH2, C double bond O, CH3. Both are same. Same answer, kids. Now, this question. H2O, H2SO4. What is the major answer? See how many questions I am going to give you. Yeah, symmetrical alkynes, you will get the same answer. Now, for this question, what will be the answer? Everyone, do let me know. C. Very good. Killer science is very fast. Wow, that's really awesome that this is going to be the correct answer. Now, HBO reaction, what should be the answer? Arthi, killer science, Vedhajanani, man, wow, really active. Kids, you can see I'm telling you the concept, I'm giving the questions. Nowhere in the whole India, entire across the country, you're not going to get such type of NCERT based handwritten questions. So tell everyone that what the fantastic diamond thing you are going to get. Everyone make a promise that you are going to share with each and everyone that this channel, on this channel, your HSP Baba is really giving you what pure thing and which is directly is expected for your examination. See, and everyone, at least one student can share with at least 3 students. At least one student, if one student is going to share with 3 students, so 15 for just 60 students will be there. And if those 60 students are going to share with 3 students, now kids, you can understand this is the chain process. In this way only we can grow. And if you are sitting, if you are studying, then definitely we can form a big group. Now, what's the answer of this question? A, B, C, D. A, B, C, D. Everyone do let me know fast. A. Very good. Very good, everyone. Now see, without any error, you are able to do the questions. Others are sleeping and you are doing question right now. Once these things are going entering your hippocampus, now at last others will be in panic and you will be in comfort zone that yes, you have completed within correct time, right approach, right time. Now this ABCD, see with how many directions you are going to solve such type of questions. Just see to it and try to understand what answer you are going to get. Yes, fast. Here again A. Are you right? Again A, killer science. Is your answer right? Killer science. I think your answer is B. Arthi is correct. B. Betha Janani is correct. Man is correct. B. Marco. Marco. This is B is the correct answer. Killer science. By chance your answer is wrong. Right? Now, ozonolysis. See how good diagram. This is made by me only. Ozonolysis. How many of you are ready for ozonolysis? Do let me know that yes sir, we are ready. Yes sir, we are ready for ozonolysis. How many of you are ready for ozonolysis? This is the backbone of your NCERT and the NEET syllabus. This is the backbone. Now, are you with full of energy? Full on? How is the Josh? We are going to study ozonolysis. Very important. This is really very important. Try to understand ozonolysis. See, ozonolysis. Ozonolysis. What is this? Not able to write. Wait. Ozonolysis. Let's see, computer is able to catch. Yeah, computer is able to catch. Now, ozonolysis. We are going to deal with ozonolysis, and this is the best thing for examination. Ozonolysis. Number of questions will be asked from ozonolysis. I hope that everyone is ready for ozonolysis. Now see, everyone try to understand what is ozonolysis. Ozonolysis is of two types. Let me tell you, ozonolysis is of two types. What are these two types? Ozonolysis is two types. Reductive ozonolysis and oxidative ozonolysis. Reductive ozonolysis and oxidative. Reductive and oxidative. This is very important. This is very important. Reductive ozonolysis is very important. It is going to play very important role. Very important. Once if you are able to understand reductive ozonolysis, you will be able to understand oxidative ozonolysis. Now try to understand what I am going to tell you. So heading is reductive ozonolysis. Reductive ozonolysis. Reductive ozonolysis. Now suppose if I say I'm provided with R1, R2, C double bond C, R3, R4. These R can be alkyl group or hydrogen groups. These R can be alkyl, R can be hydrogen or alkyl. They can be same, they can be different. Same or they can be different. They can be same or they can be what? Or different. Doesn't matter. Now, if you are going to react it with ozone, what is going to happen? See, if you are going to react it with ozone, O3 is unstable. This O3 will attack on this pi bond. This O3 will attack on pi bond. Now, once this oxygen and one more extra oxygen is going to form ozone, that is going to attack on pi bond, it will make this alkene unstable. See how CR1, R2, CR3, R4, and you will get oxygen, oxygen and oxygen, -1, -1. You can see peroxide linkage is there. Peroxide linkage has been formed, and you know that peroxide is being unstable. It is being unstable, so we have to keep it in bracket. Bracket is indicating that something is unstable, so it needs protection. This is unstable. Why it is being unstable? Because of peroxide linkage. This is known as monoozonide. Why monoozonide? Because this was having just one pi bond. So monoozonide. Now, in reductive ozonolysis, you will react this compound with zinc and water. Now see what is going to happen. This is really very, very important. What is going to happen? See, this carbon is saying, I will keep one oxygen. I can manage one oxygen. That carbon is saying, one oxygen will be managed by me. Now zinc is saying, one oxygen is left. That is mine. That oxygen is being mine. So zinc will react with this oxygen and will form JANO, ZNO. Jan will convert to JANO. Zinc has converted to ZNO. Now what products you are going to get? See, you will get R1, R2, C, R3, R4, and oxygen is there. Oxygen and oxygen. Can you see? Once again I am going to write. So that it should go directly to your brain. Just try to understand what I am writing. Everyone see to it. R1, R2, C, R3, R4, what? Double bond O. Is it clear to all of you? Now, in the examination, you won't be able to get this much of time. You need speed. Along with accuracy, speed is also required. Now, what you are supposed to do, see, don't go for that step. Directly, short trick. See, everyone see to it. The short trick I am going to tell you. Everyone, are you ready? Are you ready for the short trick? I'm going to tell you the short trick. Just try to understand. Along with sigma, break the pi bond also. And O low. Give from the point where you have broken down this bond, give oxygen. Along with sigma, break pi bond also and O low. Along with sigma, break pi bond also and O. Along with sigma, break pi bond also and give them O. Along with sigma, break pi bond also and give them O. Are you able to understand what I am saying? Everyone, do let me know. Are you able to understand or not? Along with sigma, trick is along with sigma, break pi bond also, and give them O, and give them O, give them give them O. So this trick will help you a lot. See how the trick will work. Just try to understand how the trick is going to work. See to it. Everyone, see, these are the questions which has been asked in your examination. Ozonolysis, reductive ozonolysis. What is the trick? Along with sigma, break pi bond also. Along with sigma, break pi bond also. Give them O. Along with sigma, break pi bond also. Give them O. Along with sigma, break pi bond also, and give them O. Along with sigma, break pi bond also, give them O. Now, one thing, all these are symmetrical, so you got same type of product. All these were symmetrical alkenes, so you got same type of product, only one type of product, because this was symmetrical alkene, so you got only one type of product. Are you able to understand? One type product you got. This is also symmetrical alkene, so you got one type of product. Symmetrical alkene, one type of product. If I do the reverse, if I talk about the reverse, if we are getting same type of carbonyl compound, that means alkene is symmetrical. Alkene is symmetrical. Now see, this compound, how many pi bonds are there? This question has been asked in IIT. This is having 1, 2, 3 pi bonds. Now, how to do it? How to do it? Along with sigma, break pi bond also. Along with sigma, break pi bond also. Give them O. Give them O. Just see, you have broken from here. You have broken this from here. So give O. Give O. Give O. Now here, give O to both sides. It has gone. It has gone. CH double bond O, CH double bond O, and CH2 double bond O. Is it easy or tough with this trick? Along with sigma, break pi bond also. O. Do let me know. So these two are same. This is methanol. This is methanol. Or you can say formaldehyde. Formaldehyde is the general name. So if I say this is X, then these two are same. These are known as glyoxyl. Glyoxyl. And this is Y, then this is going to be X. You are going to get two types of products. Are you able to understand? Do let me know. Everyone is able to understand. Then I am going to give you the tough one. See, benzene ozonolysis. If anyone is going to ask, do the ozonolysis of benzene, what you are going to get? See, with the trick only, it will become easy. It will become easy. See, now all carbons, they are attached with hydrogen CH. Now what technique you have to apply? Along with sigma, break pi bond also. O low. Now this has broken from these two sides, but this side is intact. This side is intact. So 3 moles of ozone will get consumed. Why 3 moles? 3 double bonds are there. O3, zinc and water. You are going to get compound like this. See everyone, what you are going to get? This will remain intact. This will remain intact. This will here it will remain intact, and here it will remain intact. So you are going to get product CH double bond O, CH double bond O glyoxyl, CH double bond O, CH double bond O glyoxyl, CH double bond O, CH double bond O. That means 3 moles of glyoxyl you have got. Symmetrical product 3 moles of glyoxyl, 3 moles of glyoxyl. If examiner is asking how many types of carbonyl products, if examiner is asking how many types of carbonyl products, then the answer is only one type of carbonyl product, one type of carbonyl product, one type of carbonyl product. Are you getting my point, kids? Now, this is the really best question which I am going to give you. This, try to understand. This has been asked in AIMS. It has been IUPAC name of glyoxyl. See, what is the IUPAC name? 1, 2. The IUPAC name is ethane 1,2-diol. Ethane 1,2-diol. Ethane 1,2-diol is the IUPAC name. Are you able to understand, kids? IUPAC name is ethane 1,2-diol. Now this is the best question. Already it has been asked in AIMS. Has been asked in AIMS and IIT. Try to understand how many types of carbonyl products you are going to get. Let me know in the chat section. I'm waiting for your answer. Everyone, do let me know how many types of carbonyl products you are going to get. Very good, Aarti. I want to see that how many types of products everyone is going to get. Carbonyl products. How many types of carbonyl products? 1. Sarla Sundar is saying 1. Let me check out for other students what the answer they are going to get. So this is anaconda question. What do you mean by anaconda question? That mostly students are going to get wrong answer. Anaconda question. Anaconda question means maximum students are going to get wrong answer. 99% students will get wrong answer. This is the meaning of anaconda question. Should I explain? Wow, Sarla, Sundat, Killer Science, Bhartan, Santhi, everyone's answer is correct. How you did it? I'm unable to understand. 3 is the correct answer. How you did it? That's really awesome. Unbelievable answer you kids have given. See how to do it. Just do let me know. Is this orthoxylene? Do let me know. Is this orthoxylene? Is this orthoxylene structure correct? Is it the structure of orthoxylene? The yellow one is orthoxylene or the green one is orthoxylene? Do let me know, everyone. I'm waiting for your answer. Which one is orthoxylene? The yellow one or the greener one? Which one is correct? Which one is correct? So the answer is both of them are correct. Both of them are correct, isn't it? Yellow one. No, killer signs, both, killer signs, both. They are the resonating structures. Both of them are the resonating structures. Double bonds position is not fixed. This is the point. Double bonds position is not fixed. That double bond is rotating. Double bond is doing resonance. Double bond is delocalized. This is the point to be noted, my lord. This is the point, important point. Now, if we do the ozonolysis, it will break from here. And if it is breaking from here, so this carbon is attached with methyl and this carbon is attached with hydrogen. What you are going to get? See, everyone. So by chance your answer is, you got the correct answer. That's by chance only, I think. If you're not able to apply this thing. Now see, try to understand what answer you're going to get in that one. You will get CH double bond O, CH3 double bond O, right? Here, now here CH3 double bond O and CH double bond O, these two are same, and here CH, what are you going to get? CH double bond O and CH double bond O. This is glyoxal. This is being glyoxal. And in glyoxal, one methyl is added. What will you say? Methyl glyoxal. Now everyone see, these two are same. And this two types of products you got from here. This two types of product. Now do the ozonolysis of this. This bond will break from here, but it will remain intact. So you are going to get CH3 double bond O, CH3 double bond O. Now two methyls are there, so we'll say dimethyl glyoxal, isn't it? Now it will break from here, you will get glyoxal. Here also you will get glyoxal. CH double bond O, CH double bond O, CH double bond O, CH double bond O. So glyoxal to you got there also. So how many types of carbonyl products you have got total? So the answer is 3 types of products you got. One glyoxal, dimethyl glyoxal and methyl glyoxal. Everyone able to understand or not? Do let me know that. Are you able to understand it or not? Kids, I'm waiting for your response in the chat section that everyone is able to understand or not. Do let me know that yes, that's really awesome that you are able to understand. Now, this is going to be what? Oxidative ozonolysis. But before doing questions of oxidative ozonolysis, let me explain what is oxidative ozonolysis. But before going to oxidative ozonolysis, let me tell you reductive ozonolysis of alkynes. Reductive ozonolysis of alkynes. See, it's very simple. Once you are able to understand that, this you will be able to understand R, C triple bond C, R dash. These two R's can be same or they can be different. R can be same or different. R can be hydrogen or alkyl, same or different. Anything is possible, no problem. Now what you are supposed to do? The same thing, O3 zinc and water. O3 zinc and water you are going to apply. Now oxygen needs just 2 valency. So just break 2 pi bonds. No need to break sigma bond. No need of breaking sigma bond. Just break 2 pi bonds because one extra bond is there. So R, C, C, R dash, and you have broken 2 pi bonds. Put oxygen like that. Very simple. This one is really very simple. No need of breaking the sigma bond. Sigma bond will remain intact. For example, if I give you one reactant CH, triple bond CH, what you are supposed to do? O3 zinc and water, O3 zinc and water, CH, double bond O, CH, double bond O. Simple. It's very interesting. Now see, if I give you CH3, C, triple bond CH, what answer you are going to get? It's really simple one. CH3, C, double bond O, CH, double bond O. Alkynes ozonolysis is very simple. Ozonolysis of alkyne is very simple, isn't it? Isn't it? Do let me know. Ozonolysis of alkyne is very simple. Now, I'm going to deal with oxidative ozonolysis of alkenes and alkynes. Is everyone ready? Then we can do number of questions. Number of questions. We are going to kill all the questions based on this, so that NCERT will look very simple. So everyone ready? Now see. See to it. Oxidative ozonolysis of alkenes. Oxidative ozonolysis of alkene. Oxidative ozonolysis of alkene. This is really very interesting. It is really very interesting. See, the same alkene I am going to take. Earlier I took R, R2, R3, R4. Just try to understand what is missing over here. O3, first I am using O3. Once I have used O3, ozonide was formed. Ozonide was formed. C, R1, R2, oxygen, carbon, oxygen, oxygen, R3, R4. This you know very well. This was unstable. This was unstable. Do you remember? Everyone, do you remember? Yes, sir. We remember. This was ozonide. Till now the same. Till now it's same. Now, after this, what they are saying in oxidative ozonolysis, just use water. Zinc is missing over here. Zinc will not be given. Zinc will not be present. Now what is going to happen? Just try to understand. This carbon is saying I will take one oxygen. This carbon is saying I will take one oxygen. So this oxygen earlier was taken by zinc. Zinc has formed ZNO. In the reductive ozonolysis, when zinc was present, zinc has taken away this oxygen and that has formed ZNO, but now zinc is not there. Who is going to take this oxygen? So water is saying, hey, I will form a bond with you and will form H2O2. It will form H2O2, hydrogen peroxide. It will form hydrogen peroxide. Hydrogen peroxide. Now, it has formed hydrogen peroxide, and hydrogen peroxide is mild oxidizing agent. MOA. MOA stands for mild oxidizing agent. Now, it is being mild oxidizing agent. Now, earlier we know that whatever the products has been formed, let me write down those products: R1, R2, R1, R2, C double bond O. This we know very well, C double bond O, R3, R4. Now, this to same. What is going to happen over here? What's new thing is going to happen over here? See, this H2O2 will say, I will attack on you, I will oxidize you. H2O2 is saying, I will oxidize you, I will do the oxidation, I will do the oxidation. Now, movie will start from here. Movie is going to get started from here. You know, H2O2 is mild, means weak oxidizing agent. What do you think? Weak oxidizing agent cannot oxidize ketones. Weak oxidizing agents can't oxidize ketones. They can just oxidize aldehyde. If you remember this point, your answer will be clear. Just to remember one point. What is the point? H2O2 can only oxidize aldehyde. Ketones will have no effect. Ketones will not be affected. Ketones will not be affected. This can oxidize only aldehydes. Ketones will have no effect. Ketones will remain inert. Ketones will not be affected. Ketones will not be affected. Now see how the question will come and how will you do this. See, let me explain. Let me explain. See to it. If the question is coming like this, CH3, CH double bond C, CH3, CH3. Now, they have given like this, O3 and water. So what type of ozonolysis is this? Zinc is missing, so it is oxidative ozonolysis or reductive. First of all, let me know. First of all, everyone, let me know this is oxidative or reductive. So it is indicating that it is oxidative. Zinc is missing, so it is oxidative ozonolysis. Now, first of all, form the product like reductive ozonolysis only. Just you are dealing with reductive ozonolysis. So what do you get? Break sigma and pi bond. Now you will get CH3, CH double bond O plus C double bond O, CH3 and CH3. Now are you able to understand which one is aldehyde, which one is ketone? So it's very clear. This is aldehyde. How to find out aldehyde and ketone? How to distinguish? If this hydrogen is there on carbonyl aldehyde and no hydrogen, both are carbon, so this is being ketone. Now H2O2 will say, I will attack on you, and I will attack on you. So on which compound H2O2 is able to attack? Ketone will say, no effect, I am being inert, I am being stable, you can't do anything to me. Now aldehyde will undergo oxidation. Aldehyde will oxidize and it will convert into acid. So what are the two products? One acetic acid and one ketone, acetone. These are the two products. Is everyone able to understand? If you are not able to understand, let me give you another example. Should I? Let me give you another example. Those who are unable to understand, let me give you another example. See to it. Everyone see to it. Just see to it. Suppose if the question is given like this, CH3, C double bond C, CH3, and on the arrow it's written O3, zinc and water. O3, no, zinc is missing, water only. Zinc is not provided. Now this is oxidative or reductive. Now see, just break the pi bond from here. You have broken. Now you will get 2 moles of 2 moles of acetone. Is this ketone or aldehyde? Do let me know. Is this aldehyde or ketone? Everyone do let me know. Aldehyde or ketone? Definitely this is being ketone. And if this is being ketone, H2O2 is going to attack on it. What H2O2 will do? H2O2 won't be able to attack, no further reaction, so you'll get answer same. Even if I am going to do reductive ozonolysis, what answer you are going to get? O3, zinc and water. If I am doing reductive ozonolysis or oxidative, this is being oxidative ozonolysis, this is being reductive ozonolysis. In both the two cases, I am going to get the same answer. Same answer here also. I will get 2 moles of acetone because ketones are not affected by H2O2. Everyone is able to understand. Now, in place of this, suppose if I have given question like this, that CH3, CH double bond CH and CH3. Once you are going to do reductive ozonolysis and once you are going to deal with oxidative ozonolysis, suppose this question and this question, try to understand what is the difference in between two questions. O3, zinc and water is given. O3, water is given. So first try to understand which is being reductive, which is being oxidative. Zinc is given. So this is being reductive ozonolysis. And reductive ozonolysis reaction will get stopped over here only CH3, CHO, because H2O2 is not formed. But in this reaction, zinc is missing. Zinc is missing, so H2O2 will also get formed. And that H2O2 will attack on this aldehyde. And this aldehyde will not be able to survive. And that H2O2 will convert this aldehyde to what? This H2O2 will convert this aldehyde to 2 moles of acid CH3COH. So this will form but will not remain. So what are the answers? Here this is the answer. Here this is the answer. Here the reaction will get to stop at aldehyde only, and here the reaction will reach. Wow, that everyone is able to understand. Kids, is this has become easy or still it is tough? Now, once if you are able to understand it, let me tell you one note. Let me give you one note that is really very, very important. Try to understand. Now see, in case of formaldehyde, this is very, very important note. Number of times questions has been asked. This is note. In case of formaldehyde, H2O2 will attack on formaldehyde. How formaldehyde looks like? HCH double bond O. H2O2 will convert it into HC double bond OOH. But this is formic acid, and there is very, very special thing about formic acid. Formic acid, there is very, very special thing about formic acid. Now you will ask, what's that, sir? This is the only carboxylic acid in this world. Only carboxylic acid in this world, in this whole world, with CHO group. Being acid, carboxylic acid, it is also having CHO group. From this side you will see CHO, and from this side you will see COH group. It is bifunctional. It is being bifunctional. This is the only carboxylic acid in this world which is having CHO group, and H2O2 will attack on this twice. On other acids, it was not able to attack, but over here once again it will attack, and it will convert into CO2 and water. CO2 and water. So the final product in case of formaldehyde is H2O2 and water. This is the reality. Now, how the question will be asked on this? question will come like this. Everyone see to it. If they are giving you question like this, CH3 CH double bond CH2. Now they have given you question like this, O3 and water, O3 water. Just break it from here. First you will form CH3 CHO and CH double bond O. Now these will formed but not remain like this, because H2O2 will oxidize them, because zinc is not there. H2O2 will get formed and H2O2 will attack on these. This will get converted into CH3 COH. So this is one of the product, and this will convert into formic acid, but formic acid is unstable. Once again H2O2 is going to attack on this, and H2O2 will convert this into CO2 and water. So what is the final answer? Examiner is asking what is the final answer of it. So acetic acid, wow, Vidhajanani, you have written even more faster than me. I have written now, and before me only you have written the answer. That's really awesome. Great. You're faster than me. So everyone is able to understand. Is everyone able to understand? Now let's deal with oxidative ozonolysis of alkynes. Then I will give you one gift, right? Just wait for the gift. But first of all, let me tell you oxidative ozonolysis of alkynes. It's very simple. Once you are able to understand alkene, you will be able to understand alkyne. Just try to see to it. Oxidative ozonolysis of alkynes. Kids, you must be thinking that this teacher is not giving break. So what do you think? Thank you. If you are able to understand, that's really awesome. That others teacher are giving you break in the morning session also. Just do let me know. And if you need break, then I will think for it. Or without break should be moved. Do let me know, kids. It's your energy level. If your energy level is still there, I will move without break. And if you're feeling low in energy, I will give you a break. Just think about it. Oxidative ozonolysis of alkynes. This is very important. Something very okay. That's really fantastic. Now something very important in this. Just try to understand. If I write R1 C triple bond Cr2, and if it is given like this, O3 zinc and water, O3 zinc and water. No, zinc is not there. If zinc is there, then the same, O3 and water. Just break 2 pi bonds. No need to break sigma bond like in reductive ozonolysis we did. Now you will get R1 C double bond O C double bond O R2 plus H2O2 will get formed. H2O2 is being mild oxidizing agent. MOA. That means mild oxidizing agent. Now it will try to attack. This is being, if R carbon, then it can be ketone, or they are hydrogen, then it is going to be aldehyde. So it can be aldehyde or ketone. Now one thing is very special over here. On ketones, H2O2 was not able to attack. But if ketone is like this, these are special ketone. Why these are special ketone? If they are being ketone, then they are special ketone. Why? What's special in this? Because they are adjacent diketone. Adjacent. So H2O2 will attack on it. This is a special thing that H2O2 will attack on it, and you are supposed to break it from here, and you will get R1 COOH plus R2 COOH. These are the products. Simple ketones are not affected by H2O2, but these special ketones, diketones, will be affected by H2O2. Wow, that's really everyone is studious. Now, these diketones will be affected by, that's really awesome thing, these diketones will be affected by H2O2. Now, let me give you some examples so that you can understand it. Try to understand it, everyone. Suppose if I am going to give you compound like this, CH3, C triple bond C and CH2, CH3. You can see R1 and R2 is being different. These two are being different. This is R1, that is R2. And if you are doing ozonolysis, that is being oxidative ozonolysis, if O3 and water is given, what you are supposed to do? Just try to think in your brain. And if whatever thinking in your brain, if I am writing same, then you can show me the thumbs up that break pi bond from here. Break this pi bond from here. You will get CH3, C double bond O, C double bond O, CH2, CH3 plus H2O2. Now H2O2 is being mild oxidizing agent. It will oxidize from here and this will break from here and it will convert into two acids. It is going to convert into two acids because H2O2 is being mild oxidizing agent. It will convert it into CH3, COOH plus C double bond O, OH, that means COH, and CH2, CH3. This will be the product. If you're also getting these two types of products, you can show me the thumbs up. If you're not getting these two type of product, then thumbs down. But try to respond, okay, everyone? Now see, if I give you something like this, CH3 symmetrical alkyne, CH3 C triple bond C and CH3, and it's written over here O3 and water, O3 and water. What you are going to do? O3 and water. Now just break two pi bonds, just break two pi bonds, this pi bond and this pi bond. What you are going to get? You will get CH3 C double bond O, C double bond O and CH3. You can see R1 and R2 being same. This is being R1 and this is being R2, these being same. So you are going to get symmetrical acid. You are going to get symmetrical acid. So what's the answer you are going to get? That H2O2 formed being mild oxidizing agent will oxidize it and we have 2 moles of CH3 COOH. Am I right? Now I'm going to give you one special question to you. Now just try to understand it. What is special about this question? See, if I give you this thing, CH triple bond CH and O3 and water has been provided. O3 and water has been provided. What you're supposed to do? Just this pi bond and pi bond, break these two pi bonds, you get H, C double bond O, C double bond O, H. Now this will oxidize. H2O2 is going to break them and the H2O2 hydrogen peroxide being mild oxidizing agent will form formic acid. That means 2 moles of formic acid. But you know very well this formic acid is a special acid. This is very, very special. What's special about it? What's special about it? I've told you the special thing about it is having CHO group. So it will get formed. This got formed, but they will not remain alive. This has to get converted into what? Because H2O2 says, I will make you what? CO2 and water, CO2 and water. Kids, are you able to understand? So the final product is CO2 and water for this reaction. This is answer. Everyone got it? Everyone do like, wow, Arthi, man, everyone has written. You have to become super intelligent. Oh my God, I can't believe I was writing over there. Before me, you have written. That's fantastic. Stupendous performance. I'm feeling accomplished. Now, everyone, really, now, once you are able to understand oxidative ozonolysis and this, let me tell you, I was talking about giving you gift. So see what gift I am going to give you. Just try to understand what gift I am going to give you. Like oxidative ozonolysis, what I am writing? Like oxidative ozonolysis, we will get same products if we react alkene or alkyne with KMNO4 acidic medium or hot and concentrated KMNO4 or K2Cr2O7 in acidic medium. Now Wasim sir has told you that these are being strong oxidizing agent. I hope that you remember that these are being SOA. These are being SOA, strong oxidizing agent. Strong oxidizing agent. Now, these reactions are given in your NCERT. Number of reactions are given in NCERT. No need to learn about them. Once you are able to understand oxidative ozonolysis, these will give you same type of products. Is this good or not? Everyone do let me know, is it good or not? That once if you are having command over oxidative ozonolysis, you can do number of questions. If you are able to understand, do let me know. Now we are going to deal with these questions. This already I have told you, and this we have done, this also we have done. Now kids, now it's your time. Now it's your time to let me know what answer you are going to get over here and what answer you are going to get over there. Just think over it. If whatever I'm writing, that's coming to your brain, then you have to put thumbs up, otherwise thumbs down. Ready? Everyone ready? So this is oxidative ozonolysis and I'm writing the final product. If you are agreed, then say yes. CO2, water, intermediates I am not writing, and CH3, COH. I have written directly final products. Final products directly I have written. These are the final products. Process I have not gone through. And here, this is reductive ozonolysis. So formaldehyde plus acetaldehyde, CH double bond O, CH3. These are the final product which I have written. So agreed. If agreed, show me the thumbs up. If not agreed, then say, yeah, I can see the final product also you're writing, and I want to see thumbs up, thumbs down. So, next, another question, that this is what ozonolysis, this is what ozonolysis, that you have to understand. This one is, I would like to say, oxidative ozonolysis. First thing is that to understand oxidative ozonolysis or reductive ozonolysis, this is being oxidative ozonolysis and this is being reductive ozonolysis. Now, for oxidative ozonolysis, reductive ozonolysis, I would like to say the product will be same. In both the two cases, the same products will get formed. Agreed or not? Yeah, very good. Zinc present, reductive. Very good. Now, I am saying that in both these two, you are going to get the same products. Agreed or not? First, do let me know that are you agreed with this point or not, that in both of these two cases, you are going to get same products. And the product is 2 moles of acetone. Is this valid or not? Same products you are going to get. Acetone. Acetone is being journal name. Acetone is being journal name, or you can say trivial name, or you can say common name. And propanone is the IUPAC name. Propanone. Propanone is being IUPAC name. Agreed, everyone? Wow. Agreed. Everyone agreed. Now, another question. Once again, this is being reductive, that is being oxidative. I'm going to write directly product. Just you have to let me know, agreed or not. CH3, COOH, and acetone. 1 mole of acetic acid, 1 mole of acetone. In this oxidative ozonolysis, I will get these two products, these two types of products. And here in reductive ozonolysis, I will get CH3, CH double bond O, and acetone, C double bond O, CH3, CH3. Reductive ozonolysis, I am going to get these two type of products. Agreed or not? Agreed? Wow. Ethanol and acetone. That's really fantastic. That is acetic acid. There is being acetic acid. It's being acetic acid and acetone. And here is being acetaldehyde or ethanol. Ethanol, we can say IUPAC name. Acetaldehyde is being journal name. And acetone. Fantastic. See my homework, how many questions I have found. Kids, are you agreed with this point, that how much efforts I am doing? Everyone agreed or not? New questions. I haven't copied these questions. You can see, if you are dealing with these things, you must have seen that I have never copied anything. I had, yes, definitely made these questions from the NCERT only. You know, you can understand those who have studied earlier. Akanksha Singh, fantastic Akanksha, that everyone is able to understand. Now, the question is reversed, that an alkene, some alkene is given over there, and that alkene has undergone reductive ozonolysis. Reductive ozonolysis. And it has given acetone. Only one type of product formation means what? In such type of questions, always you have to start from here. Means from right to left, you have to go. These type of questions will be given in your NCERT, NEET exam, number of places. These type of questions you are going to get. Always start from here. You got same type of product. The same type of product, only one type of product formation means what? Only one type of product formation means what? Only one type of product formation means what? This is giving a clue about that the alkene must be, its parent alkene must be what? Its parent alkene must be what? Parent alkene must be symmetrical, must be symmetrical. Am I right? That must be symmetrical. Now, how to get it? Wow. Vidha Janani, he has written even that kid has written even the answer. Now, see, this is acetone. So, let me take 2 moles of acetone. 2 moles of acetone. What I am supposed to do with 2 moles of acetone? Earlier, I have added OO. Now, I am supposed to remove OO and form the product. How to form the product? Just try to understand. CH3, CH3, C double bond C, CH3 and CH3. What is the IUPAC name of this compound? 1, 2, 3, 4. Now 2,3-dimethyl, 2,3-dimethyl and butene, right? Butene. Everyone is able to understand? Is this your answer? If everyone agreed, then try to give thumbs up. Show me the thumbs up. And those who have not, smash the like button. Kids, smash the like button so that it can reach to 70, at least 70. Then it can go to 100 or whatever. All right? Now, another question. Wow, an alkene. Once again, we are talking about an alkene, and this time ABCD has been formed. You can see the hard work done by your HSP Baba. Everyone, do let me know. C, Arthi is saying C. Let me check. 2-methyl-butene. 2-methyl-butene. Let me check it out. Acetone and acetaldehyde. So this is being acetone. This is being acetone, CH3. And this is being acetaldehyde, CH double bond O. And we have to remove oxygen. So what I will get? CH3 double bond CH3. Everyone agreed? So IUPAC in MC. Number of times students are asking, sir, how much weightage is of IUPAC? See kids, is this question of IUPAC, ozonolysis, or number of factors are involved? 1, 2, 3, 4. So 2-methyl-butene. 2-methyl-butene. Everyone's answer is correct. So this question is mixed question, right? Isn't it? Okay. Now ozonolysis is done. Now we are going to start with other topic of alkene only, and that is addition of X2. We have done addition of HX, we have done addition of water, we have done ozonolysis. 3 things we have done. Before I start addition of X2, do you have got NCERT? Kids, do let me know. Have you got NCERT? Everyone do let me know. Have you got NCERT? Have you got NCERT? Just see ozonolysis in NCERT. If you have got NCERT of class 11th, hydrocarbon part 2. Once again, I am telling you, NCERT class 11th part 2. Sir, please say oxidation with peracids. I will let you know. Killer science, oxidation with peracid. I will let you know. Don't worry. I will let you know. Right? So killer science is asking, sir, oxidation with peracid. Okay, let me tell you oxidation with peracid. Let me tell you. Oxidation with peracid. But everyone try to see, this is on public demand, oxidation with peracid. But C and CERT. Oxidation with peracid. Killer science, oxidation by peracid. The well-known peracid is H5IO6, or we can say HiO4 dot 2 times H2O per iodic acid. This question has been asked number of times but not given in NCERT. So this acid has very special thing. You have asked me, that's why I am telling you killer science. Otherwise, this I must have told you in class 12. See, this has very special thing about this attacks in between. This periodic acid has very special thing. It attacks only in between two carbonyl groups. What is the special thing about it? It attacks in between two carbonyl groups or two adjacent hydroxyl group. Or one carbonyl and one hydroxyl. This is very, very special and it's not given in NCERT. That's why most maximum students, they are not able to get 720 because it's not given in NCERT. Now see how it is going to attack. See everyone. If I say that I am provided with ethylene glycol CH2OH. Now do let me know that periodic acid is going to attack over here or not. First do let me know it is going to attack. Yes, H5IO6 will attack because there are two hydroxyl group and it will attack over here. Now how to form the product? Just break from here and the part from where it has been broken, the part from which it has been broken, put OH from your side. Put OH from your side. This OH has been added because of this H5IO6. Are you able to understand? Break in between this and from where you have broken it up, add OH from your side because this is done by this periodic acid. Now we have to understand one thing, that on one carbon two hydroxyl groups are generally not stable. This point you have to keep it in the brain, that on one carbon two hydroxyl groups are not stable, are not generally stable. So what we are supposed to do? This point you have to keep it in your brain, otherwise you won't be able to understand anything, that they are not stable. So just remove water. Removed water, we have to remove water. This OH and this H will eliminate out. What you are going to get final product? H CH double bond O and H CH double bond O Just remove water from it and you will get the answer. So this question to solved. Now suppose if I give you another question, let me see whether you are able to solve it or not. Just see to it. If I give you glycerol, the concept you are able to understand, you can do any question of this word. CH2OH, CHOH and CH2OH. This is known as glycerol. Glycerine or glycerol, whatever you want to say, you can say glycerine, glycerol. Now, how many moles of periodic acid will be required? Definitely, this can be the question. So, one to attack from here and one to attack here. 2 moles of H5IO6 will be required. It will break from here, these two positions, right? So once it is going to break, what you are going to get? You will get CH2OH broken, CHOH broken, CH2OH broken, right? Now from where you have broken it, add OH from your side. OH, OH, OH. These are unstable. What you are supposed to do? Because on one carbon, 2 hydroxyl groups are not stable. So you are supposed to remove water. Water should be removed. What you are going to get? So here you will get HCHO. Here you will get HCOOH. Here you will get HCHO. I hope this much you are able to understand. If this much you are able to understand, once the question was asked in your AIMS examination for that glucose was treated with glucose plus periodic acid. So we should know periodic acid. What is periodic acid? I have told you. What is glucose? How to write down glucose? So you should know glucose, otherwise you won't be able to do anything. CH double bond O, CH OH, CH OH, CH OH, CH OH, CH2 OH. Even this question was asked, how many moles of periodic acid will get consumed? Once this question was asked, how many moles of periodic acid? Just see, 1, 2, 3, 4 and 5. So 5 moles of H5IO6 will be required. Now just you have broken up. So you have broken up, you know very well what you are going to get. CH double bond O, only one molecule you have broken up. Now 1, 2, 3, 4. These 4 are of same type. So 4, you will get CH, CHOH. It's broken from up as well as downside. And this is only one, CH2OH. And this is broken from here. Now add OH. And you know that on one carbon, 2 hydroxyl groups are not stable. So these are being unstable. And once these are being unstable, what are you supposed to? You have to remove water. Remove water from here, remove water from here, remove water from here. So let's see what we will get. We will get, this is already no need of removal of water. See, OH and O, no OH is there. It is formic acid. It is just formic acid, HCOOH. Now if you remove water from here, you will get 4 moles of formic acid. 4 moles of water has been removed. You got 4 moles of HCOOH. So 4 moles of formic acid and 1 mole of formic acid. Just add these two. What you are going to get? 4 plus 1, 5 moles of formic acid. So total 5 formic acid we have got. And remove water from here, you will get 1 mole of formaldehyde. So this is the final answer. Killer science. Got it? See, he asked me something and I have fulfilled his wish. This is the teacher I am. I haven't said that I will tell you later on. See, now, I was asking to you kids that see your NCERT of class 11th, ozonolysis in hydrocarbons, and you are able to understand. It will require just 30 seconds. You have to see the page. You will say, oh sir, we are able to understand each and everything. Now, addition of Br2, X2, Cl2, whatever the things, see, addition of, this is really very, very important, the thing which we are going to deal with, addition of X2. This plays very, very important and it holds a hell lot of weightage. Addition of X2. Addition of X2. Just try to understand. Addition of X2. Now, if I write X2, what do you think? Let us suppose Br, out of these, one is being E, one is being Nu. I have told you E, Nu. Let us consider this is E and this is Nu. This is having lone pair. That is also having lone pair. Both of them are having lone pair. What do you think? This is a rearrangement case or no rearrangement case? In the starting, you just think part 1. I've started with chemical properties. And in the starting only, I've told you the general rule. Rearrangement case or no rearrangement case? Is this going to be the rearrangement case or no rearrangement case? Because if you're not able to understand, you won't be able to give the correct answer. So see, if anyone is going to ask that this is reactant, 5-membered ring, and this has been allowed to react with bromine water, what do you think? Product will be of 5-membered or 6-membered? If you don't know that is this being rearrangement case or no rearrangement case, you won't be able to answer it. What I am telling you, are you able to understand? What I am telling you, are you able to understand? That if you don't know, if you don't have any information, any knowledge, any data in your brain, that is this rearrangement case or no rearrangement case. Bhartan Shanti Prabha Lakshmi, wow, great name. Bhartan Shanti Prabha Lakshmi, 6-membered. So your answer is wrong, Bhartan Shanti Prabha Lakshmi. So see why your answer is wrong. Just see. If I say this is being delta because this is donating electrons, so the pi bond is going to shift on this side. This is being delta negative and this is being delta positive, and this is being nucleophilic part. This will break like Br positive, Br negative, and will act as electrophilic part. It is going to act as electrophile. So this Br plus will come and attack on this carbon, and this E part is having lone pair. So it is not going to attack only on this carbon, it will attack on this carbon also. Whenever electrophilic part is having lone pair, this I have told you, whenever electrophilic part is going to have lone pair, at least one lone pair, or mercury. Do you remember? If electrophilic part, let me tell you once again for those students, those who were not present, if electrophilic part is having at least one lone pair, or it is mercury, 3-membered ring will be formed. three-membered ring will be formed. You remember, three-membered ring will be formed. So it will look like this. It will look like this. Now, this is really awesome. When positive charge was on carbon, we said carbonium ion. When positive charge was on oxygen, we said oxonium ion. When positive charge was on mercury, we said mercurinium ion. Now, positive charge is on bromine. What we are going to say? Bromonium ion. What we are going to say? It is bromonium ion. Bromonium ion. Three-membered ring. Now, this carbon, in the morning only, I have told you, this carbon is having positive charge. I have given you the example of samosa and pizza. You were having just 20 rupees. With 20 rupees, you were not able to eat pizza because that was money was not sufficient so that you can eat pizza. But it was not that much less that you won't be able to eat samosa or toffee or chocolate. So this positive charge on carbon is not that much so that ring expansion can take place. This positive charge is not enough for ring expansion. This thing I've told you in the morning or not. It is that much so that it can allow nucleophile to attack on it. But this positive charge is not enough for ring expansion. Do remember what I am telling you. This is the very, very important point. 99% kids will go for ring expansion. And there is the success or defeat is lying that whether you know this or not, whether your teacher is good or not, whether your teacher is focusing on this point or not, that this charge, this is not pure carbocation. This is not, first of all, you have to understand this is not pure carbocation. Pure carbocation, because pure carbocation has full positive charge and there is just partial positive charge. This is not pure carbocation. This is not pure carbocation. Charge is not enough. Positive charge is not enough to allow ring expansion. To allow ring expansion. So definitely now do let me know that water not bromine negative, this nucleophile will attack from the same side or anti-attack. Anti-addition will take place or syn addition, means another bromine will come from the same side or opposite side. Because this is forming ring, this bromine will come from the opposite side, and that's why it is known as anti-addition. Anti-addition. You must be familiar with, and you have to be familiar with this anti-addition. So the product is 5-membered ring only, and this is going to be your product. Kids, number of times you must have seen that it's written like this: one bromine this side and one bromine opposite side. If you have studied well, you must have seen that they are attached like this, anti to each other. Why they are attached with anti to each other? Because of anti-addition. And during this reaction, the reddish brown color of bromine gets decolorized. This is really very, very important, that during this reaction, this is an important point to be noted, my lord. During this reaction, reddish brown Br2 gets decolorized. And that indicates the presence of double bonds. So this is the test for unsaturation. Earlier days, this has been used as the test for unsaturation. And always keep all these things in your brain. Before solving any question, you should have to have this much of knowledge. And kids, let me tell you very clearly, if this much, if you should have been there in your brain, then any type of question would have been solved by you, and you are going to get the best rank, and you would have got the best rank. What I'm telling you, are you able to understand now? So this follows anti-addition. Whenever you are going to add halogen, it will follow anti-addition. Do remember, always remember, always remember. No ring expansion is going to take place. Nothing is going to take place. This is really very, very important. Now, next is addition of HOX. But before I go to addition of HOX, this is the simple question. I'm going to deal with stereochemistry and tough question. What type of tough question can be asked? Let me tell you that. But for that tough question, try to understand. Try to understand. Anti-addition has taken place, that you know very well. If this is the question provided, CH2, this is given in NCERT, simple one, CH2 plus Br2, the answer will be very simple. Answer will be very simple. You can do it very clearly. CH2, Br and Br and Br. That's very simple. But if the question has been asked like this, CH3, CH double bond CH, CH3 plus Br2. Then you will say, sir, it's also very simple. What's the problem over here? No problem is there, sir. Yes, problem is there. See, just try to understand how the question will become tough. If you see, this compound is having 2 chiral carbons. This compound is having 2 chiral carbons. Now, the examiner will ask you one question. That is this meso or optically active? If he is going to ask some tough question, if some tough question has been asked, then he will say, just do let us know whether meso or optically active. Meso or optically active. This question they can ask you. They can ask you such type of question, and definitely in this case, you won't be able to give the correct answer. And for this, we should know stereochemistry. Now, do let me know that how many of you want to know the stereochemistry of it, that you are having energy to understand it, because you are studying for last 3 hours and 15 minutes. If you are ready, if you say that, yes, sir, I'm ready, I'm focused. Bharti, Shanti, Prabha, Lakshmi, no. Right now, we cannot answer it. Now, see, I think Bhartan, Shanti, Prabha, Lakshmi, for the first time you are coming to this channel. Are you coming? Are you studying with me for the first time? Is it your first time? Wow, 70 likes. You have liked. If you have smashed the like button, yes. So, are you liking it? Are you liking it? Do let me know. Even a single student's presence is really more than any present for me ever I could. Your presence means a lot. Now see, kids, how to do it. Before dealing with this question, you have to remember one trick. Super awesome trick I am going to give you. This trick will work everywhere. Trick, awesome trick by HSP Baba. Awesome trick. What is the trick? What is the trick? Trick is tan city तुषार कार intensity तुषार cars CSM. Is it possible to learn it? Tan city tushar car CSM. Now, this is the trick. If you learn it, it has to do a lot with mechanism, but right now I am not going to tell you mechanism because you are too small for that mechanism. But learn it. T stands for, here T stands for, do let me know, T stands for, just apply your brain. T means trans. A stands for, do let me know everyone, A stands for anti-addition or elimination, anti. M stands for meso. Now T stands for, S stands for syn. R stands for racemic. M stands for meso. C stands for cis. Have you become familiar with these terms? Tan, city, tushar car, CSM. Everyone familiar with this? Just to let me know, are you familiar? Have you become familiar with this? Then only I am going to give you the trick. And that trick will change your life. Definitely that trick is going to change your life. Everyone keep yourself hydrated also. Time to time you can have water. Now see kids. Everyone see. Look. If the alkene given is like this, CH3 C double bond C, CH3 H. Now do let me know, is this cis or trans in the chat section? Fast. Now today I will change your life towards the positive side. Is this cis or trans? Do let me know everyone. Is this cis or trans? Cis. Now everyone, you have to keep it in your brain one thing very clearly. One thing you have to keep it in your brain, that Br2 addition is anti-addition. I have told you, no? Br2 addition is anti-addition. This I have explained or not? That Br2 addition follows anti-addition. This I have told you or not? Kids, do let me know. It follows anti-addition. This I have explained or not? Now just see to it. Everyone just see to it. C, A, just complete it. If I have told you some trick, just try to complete it. C, A, fill in the blank. C, A. What should be the answer? C, A. Yeah, I'm waiting for you everyone. Do let me know. Bacha log. Hey kids, CA. So what is going to come? CA, fill in the blanks. R, car will be there, car. So this is going to be answer car. That means answer will be racemic mixture. Now racemic mixture means what? How to write down racemic mixture? See. racemic mixture I must have explained in isomerism. Racemic mixture means like this: 1 Br on this side, 1 Br on this side, H, CH3, Me means CH3, CH3. Here also Br, H, CH3, CH3. Without mechanism, you won't be able to understand anything. See kids, this is being racemic mixture. Racemic mixture. Got it? Everyone able to now see kids. Along with addition, you know, opposite of addition is elimination. I'm teaching you one thing, but you will get double benefit, bonus also. See, when I'm going to tell you about elimination reaction. So if you heat this racemic mixture with zinc, if you are going to heat with zinc, I have told you that zinc heating follows anti-elimination. This follows anti-elimination. So this will be the product. I was teaching only addition reaction, but benefit you got anti-elimination also you have learned. That opposite of racemic RAC with the car, we are just doing race RAC. With car we are doing race. Either you can remember car or you can remember race. Whatever you want to remember, you can learn it. But don't tell these techniques, these tricks to anyone. Otherwise, the whole India, across India, everyone is going to get marks. These are my special tricks. No one else should know. Only those kids, those who are coming to this channel just to boost my energy level, they should know, not others. Now see, if I take trans 1, if I have taken trans 1, just try to understand. CH3, C double bond C, H, CH3. If I take this trans 1, trans alkene, and adding Br2, definitely it is going to do anti-addition. Now try to complete it. Kids. T A, just complete T A. What I have told you, T A. What you will get? T A M. If you are not able to remember T A M, you can remember mat. Either this side or that side, whatever you can remember. So meso you are going to get meso, and meso means that it should be like this. Br, although having 2 chiral carbons, but due to plane of symmetry, this compound has been declared to be optically inactive. It is having plane of symmetry. Just see, this is the plane of symmetry. It is having plane of symmetry. So this compound has been declared to be meso. Pause. What is pause? Plane of symmetry. Yeah. Pause. Plane of symmetry is there. So this is declared to be meso. Now let me tell you one thing in 3, that if you are reacting this meso with the zinc, you will get this, because zinc heat will follow anti-elimination. So how was it? Shanti, Prabha, Lakshmi, Bhartan, agreed? You got it? Are you able to understand? Rest of other kids, are you enjoying it? Are you able to understand it? So this is really stereochemistry, the best stereochemistry of Br2. stereochemistry, and this is the very, very important question of your NEET. Stereochemistry. This will increase your accuracy as well as speed also. This is going to increase your accuracy as well as speed. This is really super fantastic thing. Now, nice, thank you. Now, everyone, addition of HOX, hypohalous acid. What I'm going to teach you, addition of HOX, hypohalous acid, and this is going to be the last thing. After this, only addition of X2 to alkadine will left. If you are having energy, I will explain that, but addition of HOX, just try to understand addition of HOX. This is going to be really important, addition of HOX. Now, what is this HOX? This means hypohalous acid. Hypohalous acid. Now, either it can be given or it can be given like this also. X2 plus water. X2 plus water will form HOX, that will remain in equilibrium. That will remain in equilibrium. So either way it is given, just try to understand. Now, if we are going to compare which one is having positive charge and which one is having negative charge, that is really very, very important. Just try to understand. If I write compound like this, HOF, and if I write compound like HOCl, HOBr, HOI. So first of all, let me tell you that this compound does not exist. Which one? HOF does not exist. Now ask me why doesn't exist. This you will study in P block inorganic chemistry, doesn't exist at room temperature. So the one which doesn't exist, we have not to talk about it, because hey, you to doesn't exist. So why to talk about you? We are not going to talk about you because you to doesn't exist. So why should we talk about you? Now rest of others, they exist. Now if I write this Cl oxygen, so oxygen is delta negative, Cl is delta positive, negative, delta positive, negative, delta positive. So keep it in your brain. You must have seen number of times halogens carry negative charge, but in hypohalous acid, halogens is having which charge? Positive charge. And this is going to be E nu. E, this is E, and this is going to be nu. And E is having lone pair or not? It is having lone pair. So if electrophile is having lone pair, so which case? Rearrangement case or no rearrangement case? First of all, do let me know, is this rearrangement case or no rearrangement case? If you are able to understand this point, you can do any question of the world, that is this rearrangement case or no rearrangement case. So if electrophile is having that, so no rearrangement case. No rearrangement case. Now no rearrangement case, so anti-addition it will follow, anti-addition. Now you can do any question very easily. Now see to it how the questions will come and how to do those questions. Everyone see to it. If I am going to give you this question, plus HOX, HOCl, let us suppose HOCl is given, hypochlorous acid. The name can be given or structure can be given, hypochlorous acid. Everyone, 99% kids 99% बच्चा लोग are going to do the ring expansion. Are you agreed or not? Because they will say, oh, I know this is 5-membered ring. I don't know how to do ring expansion. Definitely they are going to deal with ring expansion. They will convert this 5-membered ring into 6-membered ring, and they will answer the 6-membered ring answer. 5-membered. Now just to let me know that 5-membered ring product will be formed or 6-membered product is going to form. Do let me know if you are able to understand. No ring expansion. This is the point to be noted, my lord, that no ring expansion will take place. If you are able to understand this thing, then really no ring expansion. This is the point. No ring expansion. This is an important point which you have to keep in your brain. Say, now anti-addition will be followed. So who is going to attack first? Who is going to attack first? This is having delta positive and this is having delta negative, and this is having lone pair. So this is electron rich. Electron rich means nucleophilic part. So electrophile will attack and this will attack on both the carbons. So you are going to get chloroneamine. What do you get? Chloroneamine, because it will come and attack in both. Chloroneamine you are going to get. CH2, this chlorine will come in both carbons life. Cl positive. So this is chloroneamine. These are also known as 3-membered ring non-classical carboniamines, or always 3-membered ring. Whenever the 3-membered ring is formed, non-classical carboniamine, this word was also used. So now the nucleophilic part will come from opposite side. Anti-addition, OH negative from opposite side. So the answer you are going to get, this is your answer. CH2, one side Cl negative and one side OH. This will be your product. Agreed or not? Everyone agreed or not? Everyone agreed or not? Kids, do let me know that everyone is agreed or not. No. I'm going to give you one question which has been asked in AIMS. Very, very awesome question. Very, very awesome question. Try to understand it, everyone. See, really good question. If I say that this is propene CH3, CH double bond CH2, and once it has been reacted with this, and this, 3 types of reactions. First time, in front of it, Br2 CCl4 has been placed. CCl4 carbon tetrachloride. Once Br2 water has been placed, and once what? Br2 CCl4, Br2 water. Only 2 things, only 2 arrows. Let me remove this arrow. This is not required. Or no, suppose if I write HOBr, 3 arrows. Just try to understand what type of answer we are going to get. Br2 CCl4. Your CCl4 is non-polar solvent, NPS. NPS means non-polar solvent. So this is not going to participate during the reaction. Just bromine will get added and you will get product like this, CH3, CH, CH2, one Br over here and one Br over here. The bromine water dechlorize. Now here You know that Br2 plus water is going to form HOBr also. So you will get mixture of two types of products. In this case, you will get CH3, CH2 plus CH3, CH2. And what you are going to get? Just try to understand. Br, this is the original one, but you will get OH and Br also. Two types of products you are going to get. Now here you will get only one type of product, that is being CH3, CHOH, CH2, Br. So whenever somebody wants to add bromine only, then he has or she has or that person has to use Br2 carbon tetrachloride. If water has been used, then you are not going to get only same products, one product. You will get mixture of product, mixture of products you will get. Everyone is able to understand. Now on the basis of this, I'm going to give you one question for rank deciding question for top 50 rank. Okay, just try to apply your brain and let's see whether you are able to do it. Top 50 rank question. Okay, everyone will not be able to solve it, but at least you can try. Top 50 rank question. If you want to go to AIMS Tally, then only, otherwise no problem. So question is, which one is least likely to be formed? Least likely to be formed, or can be asked will not be formed, or they can give you question which can't be formed. Least likely to be formed, or they can give you will not be formed. Okay, everyone agreed? Which one is least likely to be formed? Now the question is CH3, CH double bond CH2 plus NaCl or Br2 and 1% aqueous NaCl. One percent aqueous NaCl. Okay. So options given are option A, CH3, CH, Br, CH2, Cl. Option B is CH3, CH, Br, CH2Br. Option C, CH3, CHOH, CH2Br. And option D, CH3, CHCl, CH2Br. Mind game question. Awesome question. Really awesome question. Try to do it. Let's see what answer you are going to get, kids. Everyone try to answer it. Yes. Wow, killer science. How Is it possible that everyone is able to think for such type of question? It's really awesome. Let me see whether you have gone through the correct path or not. This is the correct answer. Everyone is saying A. How is it possible that you are able to think for it? Unbelievable, really unbelievable. It's really fantastic how you did it. That is the question now arising. Now, let me explain and just try to understand that you have applied this brain only or something else. See, I'm going to explain it. CH3, CH double bond CH2. And how many things are there for attack? Br delta positive, Br delta negative, right? And NaCl. NaCl means if I write NaCl, so Na positive, Cl negative, and aqueous means water, HOH. These many things are there. Can you see anywhere electrophile? Only this is the electrophile. This is being the electrophile. Nowhere else is being electrophile. Only one electrophile is present. An electrophile has to attack. An electrophile will attack over here. An electrophile, once attacked, it will form a bond. Bond will be like this. CH3, CH, CH2, Br, bromonium ion, non-classical carbocation has been formed. Now, anti-addition will take place. How many types of nucleophiles you are having? 1, 2, 3. 3 types of nucleophiles we are having, isn't it? What are they? The nucleophilic part is being this Br negative, nucleophilic part Cl negative, and water. All these are being nucleophile, but attack of nucleophile will take place. Anti-addition here, they have to go and attack on this carbon only. This carbon only means on first carbon, this carbon is the position of Br. Br has to be present on first carbon. It has to be there only, the first carbon only. So see, in the first option, Br is not over here. Here is chlorine. Br has to be over here. Bromine must be present. Here. This is my logic. Means this is the correct logic. Br is here. Br is here. Br is there. Br has to be on the first carbon. So all those students, bachcha log, if you have gone through like this analysis, this process, if this was your thought process, then show me the thumbs up. Wow, that's really awesome. Really awesome. Now, in this chapter, only one thing is left. What is that? Addition of X2 to alkadine. Is everyone ready? Are you having that much of energy so that we can proceed towards addition of X2 to alkadine? Everyone, just to let me know, are you having that much of energy so that we can go with that process? That is really okay. So this is the last topic for today, and let's see what's that. Addition of X2 to alkadine. So whenever you are provided with CH2 double bond CH double bond CH2, this will come like this only. butadiene, butadiene, and in front of it, if they have given you Br2Xs, then there is no problem. No problem will arise if Br2Xs is given, because CH2, CH, CH, CH2, everywhere you have to add bromine. No problem is there. Add bromine, add bromine, add bromine, add bromine. So this is Lallu question, means very simple question. No problem is there. This is a very simple question. Very simple question. But how they can make this question to be tougher? See, they will ask like this. They will go like this. Try to understand. CH2 double bond CH, CH double bond CH2 plus Br2 1 equivalent. Br2 1 equivalent. Once 1 equivalent they have written, that means there are not 4 bromine, there are only 2 bromine atoms. Only 2 bromine atoms. So only one double bond is going to get consumed, rest second double bond will remain as such. This is the question. Now try to understand. Selva Kumar is there. Wow, Selva Kumar. See, I've started at 10 o'clock. Now it's been almost 2. Continuously I'm teaching without taking a break of a single minute. Wow, Selva Kumar, really I'm feeling happy that you are there. Now, if I do the numbering, let us suppose this is first, second, third, fourth. And this question is given like this, nothing is written on the arrow. If nothing is written on the arrow, or they can write high temperature, let me write down, nothing mentioned, or high temperature is mentioned, or 80 degrees Celsius is written, 40 degrees Celsius is written, 40 to 80 degrees, whatever is written, what major product you have to write? You have to write like this. See, CH2, CH double bond CH, CH2, 1 bromine over here, 1 bromine over here, means at first carbon and fourth carbon you can see this is 1,4 addition product. Why 1,4? 1,4 addition product, because 1 bromine has been added on first carbon and second has been added on fourth carbon, and this is formed 80%, means this is major product, major product. The second product will be like this. Second product will be like this. CH double bond CH double bond CH2, 1 bromine at this carbon, this is CH2, and 1 bromine over here is 1 and 2. This is 1,2 addition product, 1,2 addition. This will be 20%, 20% only. Now, that is 1,4 addition and this is 1,2 addition product. Now, number of questions must be coming in your brain. The first question must be coming, sir, what is this? How is it possible? That double bond was here, double bond was here, and it has come in between. How is it possible? Wow, RB Bichu Whitey, you are a big inspiration to me. How? How RB Bichu Whitey? So it's 78 likes, reached up to 78. Now kids, only 2 likes more, they can reach up to 80. Okay, now see, if I say this double bond, how many alpha hydrogens are there? This is olefinic carbon. How many alpha hydrogens? 2 and 2. 4 alpha hydrogen atoms. Can you see? 4 alpha hydrogen atoms. And in this, only 1 alpha hydrogen atom, which is more stable. This is being more stable because more hyperconjugation. So this is known as thermodynamically controlled product. The first one is known as what? First one is known as thermodynamically controlled product. Controlled product, in short, TCP. TCP, always thermodynamic. Thermodynamics deals with stability of alkene. This is thermodynamics always deals with stability. Thermodynamics deals with stability because thermodynamics deals with stability. In this world, some people think about stability, some people think about speed. You must have seen when somebody is going with car. Some people says, oh, whatever the time we are going to reach, it's okay, but don't increase the speed of car. But some, wow, thank you RB Vichuvaiti, it means a lot to me. Thanks for your kind words, appreciation. Some people says, oh, let's see, let's increase the speed of car. They are reaching up to 200 and whatever, and then sometimes they are going to meet with accident. So speed means chemical kinetics. This chemical kinetics you will study in class 12th. And thermodynamics deals with stability. Thermodynamics has nothing to do with speed, kinetics. So there are two things. One is being speed. Wow, Vignesh, that's really awesome. People are coming soon. That's really awesome. That's something good. Otherwise, I was waiting. I'm teaching for the last 4 hours. I started at 10. Very good, Vignesh. Better to call them, at least I will feel some energetic. Okay, that's your duty now, Vignesh, Selva Kumar. Okay, now then I will explain. I'm going to give you best explanation. If more kids are there, then I'm going to give you best explanation, right? It has reached to 79. Okay, make it 80, then 100 we will reach. Now going, let's see. And this is kinetically controlled product. This one is kinetically controlled product. Now what is kinetic? It is formed earlier kinetically, KCP. KCP means kinetically controlled product. Now one thing is that you can learn it, you can just keep in your brain. And another thing is that I'm going to give you the best explanation for this. What do you want? You want to mug it up, or you want to know the best explanation of this reaction? And that explanation is not only for this reaction, that is the explanation of life also. That is going to be the best explanation of life also. What do you want? Just to let me know. Best explanation. Now see, try to understand how this is possible and why this is possible. Just try to understand. This is going to be the most important reaction. Now see, this is your alkene, this is your alkadine, CH2. Just try to understand it. Okay, CH2 double bond CH, CH double bond CH2. Okay, one more thing. Let me tell you first of all one more thing, then I am going to explain. If the same question by chance they have given like this, Br2 1 equivalent, Br2 1 equivalent, and temperature is minus 80 degrees Celsius, minus 80 degrees Celsius. Now what is going to be the major product? The first product which we have formed as major product, just try to understand 1,4 addition. Earlier we said this is going to be the major product. Now this is going to be the minor product. The major will convert into minor. This will form just 20%. TCP is formed just 20%. Now this was the minor, that will be major now. What's happening? What's happening? This will be 80% now. KCP. See the drastic change. North-south pole. See, when temperature was 80 degree or 40 degree or nothing was mentioned, 1,4 addition product was major. This TCP, thermodynamically controlled product, was major. This was major. Now, once the temperature is low, this is the product. Now, you will be able to understand why 40 degrees Celsius temperature has been set to be high temperature. See, 40 degrees Celsius, I said high temperature. Why? Temperature is just relative thing. With respect to minus 80 degrees Celsius, 40 degrees Celsius temperature is going to be the means high temperature. Now try to understand, at low temperature, this KCP is major product, kinetically controlled product is major at low temperature, at very low temperature. Now, its mechanism is really very awesome, but you have to apply your brain. You have to try to understand. If you're not able to understand, just do let me know that, sir, I'm not able to understand. I will explain it once again, but once it got over, no one can help you. Okay, so let's see to it how it will work and how to see to it. Everyone, be focused. CH2 double bond CH, CH double bond CH2. Now Br2 is going to attack Br delta positive, Br delta negative. Now one Br will attack. Definitely one Br is going to attack. It will attack over here. Now it has attacked over here, that is being negative charge and this is being positive charge. What we are going to get? We will get something like this. CH2 double bond CH, CH and CH2 Br, because bromine will form bromonium ion. Once the bromine has formed bromonium ion, there is positive charge. Now, rearrangement does not take place. Rearrangement can't take place. This is very for sure. Rearrangement can't take place. Wow, Sonthar, welcome. Sonthar, welcome. Now, this is bromonium ion, 3-membered ring. Bromonium ion, three-membered ring, that is non-classical carbonium ion. So no rearrangement will take place. No rearrangement case. Now kids, even though no rearrangement case, when we are not able to move, suppose we are not able to move, we are not allowed to move, but our brain can move. During COVID pandemic, we are not allowed to move. We are not allowed to come out of the houses, but our brain was free to move. So atoms cannot move. Atoms can't move, but resonance will take place. Atoms cannot move, but resonance will take place, isn't it? Now, how the resonance will take place? See everyone. This pi bond will shift over there. This pi bond will shift over there. And if this pi bond is shifting over there, here will be positive charge. Now see what is going to happen. What is going to happen? See everyone. Right now I am having positive charge over here. Once the resonance is taking place, I will get positive charge at this place and double bond at this place. Like this. That means positive charge at this carbon, also positive charge at this carbon. So we have got two types of carbocations. This is, let us suppose, X carbocation, and this is, let us suppose, Y carbocation. Everyone is able to understand? Everyone? 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 Now see, which carbocation do you think is more stable? Which carbocation do you think is more stable? Kids, Sonthar is saying across the India organic chemistry. She is not having that type of brain. She is like good brain. She is using in a good manner. Sonthar is a very good student, you know. So just for motivation, Sonthar is saying like that. So kids, right now, for the last 4 hours, more than 4 hours, I'm teaching continuously. So this was just Sonthar was motivating me. Everyone, okay? Now see, which carbocation do you think is more stable? This carbocation is 1 degree. Both are resonance stabilized. Both are having resonance. Resonance is SBr. Full form of SBr is stabilized by resonance. SBr, stabilized by resonance. SBr means stabilized by resonance. Now this is being 1 degree carbocation. This is being 1 degree carbocation, and this is being, no, see, plus charge is over there, here, and both sides it is attached with carbon. 2 degree carbocation, and this is being 1 degree carbocation. So definitely this is being more stable. X is being more stable, and this is being, Y being less stable. Less stable. Now let us suppose in my room there is one mosquito. Okay, let us suppose in my room there is one mosquito, and just few days back in my room we had a whitewash. Now the mosquito is sitting for 1 minute on the wall. 1 minute. For 1 minute, mosquito is sitting on the wall. At the wall, better to say. At the wall. And there is one wooden thing, that is old wooden thing. The mosquito is going to sit over there just for fraction of seconds. At the wall, it is sitting for 1 minute, full 1 minute, 60 seconds. And at the wooden ball or wooden rack or whatever the thing, that bad one, it's just sitting for a fraction of seconds. Now I want to kill that mosquito. Could you please help me that where should I beat him, where to fight with the mosquito to kill him? At the wall should I hit, or that wooden rack or whatever the thing, there should I hit? What should I do? If I am going to hit that mosquito at the wall, my wall, you know, that Asian paints, Nerolic paint, whatever the paint I have used, that is going to become dirty. That's very easy to kill the mosquito at that place, but I am not going to kill that mosquito. So I have to hit at that wooden point, but at wooden point I have to hit for number of times, then only I am going to hit. Where is easy? It's easy to hit that mosquito at the wall, but it's very tough to hit that mosquito at the wooden rack. So is over here, mosquito is sitting for maximum time. This is not positive charge. Positive charge in this was there. There, the positive charge. Now, here the mosquito is sitting for 1 minute. Here the mosquito is sitting just for fraction of second. So for me, it's very easy to attack on this carbocation, isn't it? To attack means I am the Br negative and this plus charge is the mosquito. See the analogy, plus charge is the mosquito and I am being the Br negative ion. So for Br negative, what's easy to attack on this carbon or to attack on this carbon? To which carbon it can attack easily? So attack on this carbon is easy for Br negative. Br negative can attack on this carbon easily. Br negative can attack easily and Br negative can't attack easily. Br negative can't attack easily, right? Right? Now, see kids, a Br negative is going to attack easily, but the product will be less stable. If I'm going to hit the wall, I will kill the mosquito, but after killing it, my wall will become dirty, and that is not the stable thing. So attacking on this carbon is easy, but product is less stable, because after attacking on this carbon, attack is easy, but the product is not stable. See, product is not stable. CH2 double bond CH, CH, Br and CH2 Br. This is attack was easy, that means KCP product easily formed, but product is not stable. But here attack is tough, but the product stability is very good. Attack is tough, but the product stability is very good. So this is the life learning lesson. You are preparing for medical, that is NEET. The whole way is tough. To get marks is tough, but goal is going to give you stability. You can easily, you must have taken easily, very easily the admission in BSc, for the BSc or for whatever the thing, number of programs are there. Their attack was easy, but the goal is not going to give you success. So wherever the goal is really fantastic, don't think about the process, don't think about the way. It can take too much time, but always think about stability. Don't think about kinetics. Your neighbors, your friends, they must have taken admission for the BSc because they don't want to waste 1 year. They don't be called as dropper. But that process was easy, but goal is not going to give them good success, good happiness, or whatever the thing. Your goal should be fantastic. Is it relatable? That attack is easy, but product is unstable. Attack is tough, but product is stable. Attack is tough, but product is stable. Now just see, I'm going to reach up to the final thing. I'm going to, wow, Omar, Adhan, I'm going to show you the graphical representation, then definitely you can correlate it. See, I'm going to give you the graphical representation. See, try to understand. Before I come to this, let me tell you, this was one carbocation, this was second carbocation. Neither of the two carbocation were the real, they were resonating structure. If I want to draw the resonance hybrid of it, let me draw the resonance hybrid of these two. I will get something like this: CH2, CH, CH, CH2, Br delta positive. Once the carbon, this was positively charged, once this was positive charge, and the double bond. This is known as resonance hybrid. Resonance hybrid is always the true structure. Let us suppose this is Z. Let me name it Z. This is the common carbocation for both the two processes. This is common carbocation because sometimes plus charge is coming over here, sometimes plus charge is coming over here. The mosquito is not still. It is always moving, sometimes at the wall, sometimes at the wooden rack. It's moving. Now, this is common carbocation. Let me say for both the reaction, this is common carbocation. This is common carbocation. Now, let me explain the graphical portion. Just try to think. This, the reactant I have used, this is indicating energy, potential energy, and this is indicating progress of reaction. And I've started from here. This was alkadine, CH2, double bond CH, double bond CH2. I have started from here, and I got two types of product. One type of product, 1,4 addition product. What was that? CH2Br, CH, double bond CH, CH2, Br. This is 1,4 addition. Let me take a little bit upper because reactant is more reactive. Let me start from here. CH2, double bond CH, double bond CH2. Now, this is 1,4 addition product. Let us suppose its stability is this much. And here is 1,2 addition product, that is CH2Br, CHBr, CH, double bond CH2. This is more stable, that is less stable. One is KCP, one is TCP. This is TCP, more stable, that is KCP, less stable, that is 1,2 addition product. This is 1,4 addition. Everyone is able to understand? Now see. If I draw the graph, the first step is always very tough. Then this is the common carbocation, and this, for formation of this, only this much of activation energy is required. But for formation of that, this much of activation energy is required. For this much activation energy is required. Let me show you once again. For formation of this much activation energy is required. Now see, you have started from here. It is just like you, this was your class 12th. If I say this is your class 12th, this was your class 11th. And everyone has crossed class 12th. This is common point. Class 12th is common point. For your student life, this class 12th is common point. Now, this was the Z carbocation, common Z carbocation. Now, from here, two paths are there. One is you can join BSc, or you can cross over this energy barrier to reach up to the government medical seat. It is just like BSc you can do, and it is like you can reach to medical college, which requires more energy. Kids, do let me know. Definitely this activation energy is more, and this activation energy is very less. To qualify this, to reach to the BSc college is very easy. To cross this energy barrier is tough, and to cross it, high energy is required. To cross this energy barrier, high energy is required. In your case, high energy is your coaching, your study material. For this, temperature is the ultimate source of energy. So this is possible. To qualify this, high temperature is required. High temperature is required. High temperature is required. So when high temperature is given, 1,4 addition product will be measured. At low temperature, most of the reactants will qualify this only. Kids, this was the explanation. Now do let me know, are you able to understand? You liked it or not? This was the question. Either you can learn it, or you can, this is, in both the ways you will get the same answer. Either you can give the answer by learning it, cramming it, mugging it up, or you can give the answer by understanding it, because this was a really fantastic explanation. You liked it, and this is not only for the reactions. If you are able to understand, you will feel that this is valid in our life also. Our life is also like this only. Our life is also like this only. Kids, do let me know. So I've told you each and everything about alkene. Number of questions we did. Those who have joined right now, they should know that I have solved at least 50 to 60 questions we have gone through of NCERT. Right, everyone? You got it? Now I'm going to give you one question. If you get time, try to solve it and try to answer it. This is your homework, everyone. If this is your question, CH3 or CH2, C6H5 and CH double bond CH2, 1, 2, 3. If I write down that here is HBr, here is HOBr, here is Br2, we are going to get X product, Y product, and Z product. Now the question is, which will involve rearrangement? Don't answer it right now. In the comment section once the video is over, right? Which will involve rearrangement? In which reaction rearrangement will take place? You know rearrangement, hydride shift, methyl shift, or ring expansion. Rearrangement will take place. So this is the question for today. Bye to all of you. God bless you. And do remember one thing, do the proper revision. Once these things are going to definitely in your brain, in your hippocampus, each and everything will be visible. You will be able to do each and every question just in the air. And those who are not able to understand, today's there is class, so only we are not able to attend in. Okay, I got it. I understand, Santhar. I understand. But everyone, tell everyone to go through it whenever you are getting time. Thank you, sir, from Avengers Batch. Thank you. So whenever you are getting time, do remember, see to it. A number of questions, those who were not able to join it in the morning, let me tell you, see how many questions we have done. NCERT based new questions. Do let them, do solve all the questions. See how many questions, number of questions we have gone through, kids. Ready-made question, at least 50 questions we have solved based on NCERT. And these were new questions and expected for your NEET examination. Everyone, those who are present continuously since morning. Yes, it's required. Proper revision is required. Once you are doing it, definitely you are going to get the best marks. Okay, kids. Selva Kumar, Man, Killer Science, Sonther, everyone. Bye. Meet you in next session. That should be of alkyne. But before that, try to complete it. Okay. So once if you are in Avengers batch, if you are going to cover it up on the YT, you are really going to get help over there. Now, number of questions, variety of questions, you won't be able to get over there because there's limited time. There is class of 1.5 hours, and here is the class of what? How much time? 4 hours and 23 minutes. It's 23 past 2. So see, without any break, such a lengthy class. So number of questions we have done, number of concepts we have done. So bye to all of you. God bless you. Have a good time.